do. It's pretty quiet. Oh, I can just speak louder. Hello and welcome to day 2, but the main night, DATFEST 2025. See a lot of people that we saw last night, which is awesome. I'm not going to speak too long, but I spoke a little bit earlier. But yeah, just thanks for coming out. Maybe Torn wants to say something, but we're going to start with Chemistry Creative, our wonderful venue hosts. And yeah.
Yeah. Did you all get to check out some of the beginner shop over there for a second? That was crazy. That was really, really incredible to see. I know Lyle had maybe mentioned that too, but for some folks, it was the first time opening up Touch Designer, and it was really special to see the amazing projects people created for that. So hope you all got a chance to experience that. I also wanted to give a huge thank you to all the folks involved in putting this together and also highlighting some of the projects that you might have seen outside earlier in the lounge area. Is Jimmy here?
I think so. We got Jimmy in the back.
Did you all get to see the projection map piece over there? Jimmy, wave your hand. Hey! Jimmy had worked on the piece over there, the projection map piece. Definitely check that out as well. Andre's
maybe he's prepping. He's going to be talking, so we'll see a lot about his.
You'll see his interactive piece if you haven't gotten a chance to try that. And then Crystal and Brendan, can you give us a wave?
Also some wave.
Yeah. So the photo booth that's upstairs, definitely go give that a try. It's a custom-made Touch Designer piece, which is huge. Really, really fun piece to check out. And I also wanted to give a huge thank you to these two right here, Pablo and Brian. Oh my God, huge. So, and also to Chemistry Creative as well, and like all of the work. There's, oh my gosh, you all sat with us for so many hours on calls, like doing planning.
It's true.
Yeah, a lot of work. So yeah, we can do a little intro for that. And also huge thank you to Derivative. Greg and Isabel are here. Give it a huge round of applause. Yeah.
Yeah, we've got some awesome talks and several AV performances right after that. It's going to be kind of rapid fire. There are some refreshments and some movie file-ins at the bar, and also some shirts for sale. So hit us up. We'll probably just have someone stationed there, like handing things to you. So ask for it instead of like normally we just like let people grab. Yeah, maybe slightly more organized, but yeah. Thanks for coming out. Hand it over.
Thank you.
Thanks, guys. Thank you, Torn and Lyle, to Dat Lab. Woo! Seriously, what an amazing 6 months that we've been doing. It's crazy. What a great time. I'm Pablo.
My name's Brian. I'm the creative technologist here, and he's the experiential director at Chemistry Creative.
Yes, and we have that's my computer there. And I can go over here. I'll get there. Woo! All right. So you guys mostly maybe know us as a little bit of more of our Chem Studio side, which is all these meetups, Creative Code Art and Dat Lab and Creative Code NYC. Love doing these events. It's so cool to have you guys here and show your work, your processes, finding collaborations. I think it's part of why the community is so awesome, and we love hosting these types of projects and also making it possible for anyone to do a show. I'm just going to run through some of our studios things and then get into the Chemistry Creative, some of the other work that we do. But yeah, we've had art shows and more like ambient, abstract, spatial audio performances, and you guys have maybe seen some of this, the Viola album release, and that was Creative Code Art, and Sidney with his crazy laser performance. That was awesome. We've we do a lot of music videos and fashion shows and more commercial shoots here too. I mean, this is a psych, so it is great for that. Okay, Chemistry Creative, the other side of the page. This is the wider team that maybe you haven't seen too much. Maybe Monty and Martin, they're up there working on stuff. But this is kind of the core team. We scale up a lot based on projects, but this is kind of a little bit of who we are. And, you know, there's a lot of people that missed Picture Day, but yeah, this is us here, the team. Who we are. Yeah, we are a bunch of creatives, a bunch of artists trying to make cool stuff. We partner with a lot of artists and agencies and brands doing pop-ups and cool experiments. Sometimes we get to work with Touch Designer. That's Touch Designer. And sometimes it's more fabrication, that type of stuff. This is all the stuff that we've done, that we do. You know, we try to segment it into the couple different services, but you know, every project is either some of this or the whole gamut, and we really like to experiment and explore with all the different types of stuff. So you know that this space and maybe 301 that you've seen today, we also have a fab lab directly behind us. CNC, big wood shop, do a lot of the builds there. Some projects. I think we have to talk about Inter. I came to Chemistry Creative about 3 months before Inter was delivered, and Brian.
Yeah, that's how I kind of got my role here. I just like graduated college and cold emailed Chemistry Creative, and they for some reason hired me. And yeah, I was like the on-site technician at Inter. I made some of the visuals there. I helped with the dome show, and it really helped me like learn Touch Designer because I was just in this little tech room, super black, like super dark, but just did Touch Designer all day, and it just helped me learn pretty quickly. And after, I think I did Inter for 9 months, then I became full-time creative technologist at Chem. So shout out Inter.
Yeah, and I think they just recently did a whole new, like a rebrand. Now it's Intergalactic, and I think some of you here have worked on installations. Shout out Seth. Seth's been there. Louisa, awesome. But yeah, we built Inter. That was a crazy, crazy project. It was a huge undertaking. We built the dome. We did all the scenic, all the fabrication, all the tech. Installed Touch Designer everywhere and plugged sensors in the walls and made gongs like you know, get hit with mallets. It was awesome. A lot of LEDs, a lot of sound design. It was a crazy project, and it's cool to see that they are kind of taking the next step and kind of bettering the experience there. It's cool. Some more recent projects. We just finished, you might have seen this in the shop the past couple months. It was a big LED wall that we fabricated and installed a couple weeks ago at the Mercedes-Benz Stadium in Atlanta. We did all the fabrication, LED mapping, and the back-end system. It was a collaboration with an artist in Atlanta that wanted to show a little bit of the journey of people coming to the stadium. So they came to us with like the idea fully formed, which was kind of letting everyone input their zip code and then having kind of this abstract map animate with kind of the path of the from the neighborhood to the stadium. So that's been a fun project. You want to?
Yeah, so yeah, that's all Touch Designer. Shout out Roby, she's over there. She did our web development, so we got all the zip codes in the Touch Designer, got into a WebSocket, and then all of those circles are replicators in Touch Designer, and basically I created like a sequence for every single zip code or direction, and whatever zip code came in, a unique trail happen with the circles, and it kind of showed like their destination to the arena.
So if you're in Atlanta, please go check it out. It's at the AT&T Perch. Some more, a lot of LEDs. This was a cool project for Mr. Beast. If you guys know that guy, Jimmy, another Jimmy. Influencer kits. They, yeah, it was a product launch for his new toy line, and they wanted to send some crazy interactive, immersive unboxing kits to influencers. And I don't know if there's sound here. This mouse is weird.
Access granted. Unlocking vault.
Yeah, there's a lot of anxiety in the shop when that was happening. But yeah, that was cool. We did all the electronics here. We worked with BriceBot, and we did the CNC. We did all the like styling on it. We did the whole box, and yeah, the electronics. That was another one that we worked with an agency, Robot Proof, that came to us with like the idea kind of fully formed, and we made it happen. Typically, that's typical agency type of work where short timeline, crazy idea. Can we do this? Yes, of course. Yeah. There was a Google project recently that was like a prototype for them that they were testing this idea out for and like internal the school for leaders is what they have for like employees that want to move up in their roles, and they were testing this idea about what could employees kind of talk about at these conferences. And the idea here was they wanted to share books that inspired them. So we built this system. It's crazy because 6 months ago we had to use a bunch of different APIs and a bunch of different systems to get like a speech to text to Google Books API to find the book and send it to ChatGPT and ChatGPT to 11 Labs and like all this rigmarole. And now we can just use, I don't know, 6 months later, that's just, now it's so easy. It's crazy the speed of AI that's taking place. But yeah, you would pick up the phone and talk to a chatbot that's asking you what your favorite book is, and then we would find that book and then projection map it onto another book. And here we are testing things. This was a lot of fun. I don't know if you have some.
Yeah, I mean, I guess I'll like touch on the book. Like we basically put like a reflective sticker in a certain spot throughout the entire book.
You can kind of see it there in the center of the page.
Yeah, and it's like an infrared camera, and we basically mapped what page it was on based off what sticker it was and if it went up or down. And you tap your RFID, your unique book, and all your information would show up.
There's a lot to it.
Yeah, there was.
It looked like this at the end. It was a nice install. Yeah, that was a fun project. Crazy idea. Made it happen. Short timeline. It worked. Another Google project. This was another like internal employee thing where we collaborated with Kyle Morais. They wanted to do like a employee times AI times artist collaboration for this employee event, and we made this system where we took input from these forums and combined it with artwork from the artist, and then that went back to the artist, and then this is kind of the final output. These like wacky, really grew to love these designs. But that was, again, it was a lot of things happening. So for the next one, we kind of made a tighter system and a little bit nicer result. And yeah, that was kind of what the installation looked like at Pier 57. It was fun. Another permanent LED installation, a little bit cleaner and simpler. These are sidewalk vaults. The architects were inspired by, the sidewalk vaults that you might see in Soho that give light to the basements. The curation for this building was really nice. They wanted all the art to be kind of New York inspired. So that's why we use this. And then we made some animations for the lights that were inspired again by like typical New York stuff, a lot of walking, transit, and then scheduled some sunrises and sunsets. If you're in the Lower East Side, check it out, 65 Suffolk. This is more fabrication. You might have seen these in the shop next door. They're water hydration stations. Hope Hydration, a client of ours, partners, they are trying to kind of reinvent the water refilling experience to be a nicer thing. You know, you go to airports and there's usually a water fountain, but it's maybe broken or the water's not that great. So they're trying to do that. And we're building some of their stations that they send all around the U.S. for events and festivals. That's a fun project. I think this was a product launch for Monster with Hypebeast at their like retail location. We did a fun LED do the new media dance and see yourself on the screen. So that something happens, you know. Pretty fun. This is more just, you know, scenic fabrication for Maui Gym. I think it was kind of like an influencer party, DJ booth. It was I really like this clean build, really nice. No touch designer in this one. Sorry. Another type of influencer event. This was at Loom, great space. Is it Seam here? He's usually around at these. Yeah, this was fun, making, you know, wrap around 360 projections. We built this secret door, super fun party. These are like seltzer remixing machines. If you you can mix flavors and have this seltzer in your home. That's what those are. Some older projects. These were before I came in. This was like I think that you guys remember NFTs. It was a product launch for Ledger for their wallet. Yeah, when you picked up the thing, it did a thing. Another NFT thing. Yeah, we custom built these like half circle LEDs things, and did a bunch of displays. Yeah, they look really nice. We've reused those a bunch of times. Nice. Yeah, thanks. Yeah. Woo.
Amazing. We've been trying to get them to like show some of their stuff. They're like, we'll wait till DATFEST. I was like, what's that? And then we started planning DATFEST. We got Gum Gum Studio next. I have one here, and then that one might even fit on there. If you want 2 mics. And I'll let you take it away.
Cool. Hello, everybody. What's up? Oh, yeah, they'll switch over the screen in a second. We are, there it is. I mean, where is it? There we go. We are Gum Gum Studio. My name's Andy.
I'm Zancy.
And let's see if I can get. Oh yeah, it works. Okay, cool. So we are based in Brooklyn. We're a sort of, I would say, like sort of similar to Chem Creative. Like we do a lot of different stuff. We got our start in lighting installations, but we do dabble in like fabrication, permanent installations, what you're seeing here is mostly footage from parties, music festivals, that kind of stuff, but we also did the LED installation for the Telfar store, which is actually right across the street from Enter. So if you've been to Enter, you could always walk right across the street to Telfar and see our crazy DMX lighting installation in their weird clothing awning things. Unfortunately, I don't have a picture of it. So basically what we're presenting today is the system that I built in Touch Designer with Zanzi's help that controls all of our lights that we own sort of as one big system. One issue with trying to use, one issue we ran into very early on was that Touch Designer is really good at the pixels, but it does not have anything necessarily built in for controlling traditional DMX fixtures like these. So we would often use another software like a traditional lighting control console to control those. So we put a lot of work in to try and mash everything into Touch Designer, and it works pretty well. What you're looking at right now is sort of the content generation that we're gonna go through how we generate the content for the lights, and then get into a little bit more of the nitty-gritty of like how Touch Designer actually takes that content and applies it to the lights. So how does it work? I'm gonna shift us back over to duplicate here. Give it a second. Okay, cool. So Zanzi, do you wanna go over kind of how we make stuff for the lights?
Yeah. So sorry, can everyone hear me? I mean, there's a lot going on in the control system to like facilitate everything, but the core of the like content generation system is this generator that we've iterated on a bunch of times, which is in the corner here, but it generally functions on this idea of having these two kind of like alpha mask generators. This is a circle one that have these basic like controls of like width and period. You know, there's a bunch of different versions of it. Speed. Oh, I see. That's where you hit it. Okay. So yeah, you know, and I think like the circle one is a good example of one. Noise is a great one where it scale, width, speed of control, speed of like up and down. But there's basically these two alpha generators that then feed into a effects engine. That has a lot of I guess I can show you the effects system. Oh, here it is. That has like echo and distort. I think here's a lot of going around here. Okay, here it is. There's distort. I mean, it has basic things. There's these clean generators. They go into like this first layer of an effect system that can either distort the image, can blur the image, can like you know, warp it in different ways. And then it kind of goes into color. Our color system has two colors. Oh, okay, so it's here. There's a few different ways of controlling it with like kind of projection mode, which has, you know, here's you can kind of send projections over it, up and down. I think there's a circle one over here. There it is. You can control the speed of the projection, the amount of projection. And then after the color, there's a second effects engine, and the core like idea of the kind of effects generators that you combine these like generators, you distort them, you color them, and then you can like add this like another like kind of like mastering layer of effects on top of it. A lot of the effects, the most important, I mean, a lot of the work we do is for raves. It's for places that aren't necessarily like, like phones aren't allowed. They're not really for images. So the most important aspect of parties and party lighting is kind of it's like the contrast of lights, like how much light, how much darkness is in them, and this kind of like two-tiered effect system that we have in here kind of allows you to like tune not just like the speed and like what the content is and what the pattern, but like kind of the most important thing for at least like a party, for like especially large scale parties that aren't performance based. They're for DJs. They're like, it's not like centered on like a visual like point, is this kind of control the of like how much light, how much darkness is, and how like it's like almost like the blur and the distortion of the image is more important. And yeah, I guess that's the core of our effect system.
Yeah,
Anything
so
to
that's how we generate the content for the lights, and then I'll hop back in and sort of get into more of the like touch designer solution for specifically. We'll go over DMX fixtures first because that's something that I'm sure many other people have figured it out, but I don't think there's a lot of stuff online necessarily for not just a way of controlling DMX fixtures, but a way of controlling them that is one of the most important aspects of building this system is that I don't know where the lights are going to be until we have put them up. So I don't plan all of this stuff like a week ahead of time. We kind of show up to the party, we put the lights in place based on the venue and where we want them, and then I need a system that isn't, total torture to get all the lights patched in, addressed, and placed kind of on the texture where they need to go. And by that, I kind of mean like, the mapping of like how these patterns get applied to the lights depends on sort of, if you want to think about it in a weird way, where the lights are on the whole texture. So like here you're seeing the entire texture, but the lights are only sampling, individual pixels of the texture based on where they are. And we'll kind of see a better visual representation of that here in a second. So the DMX fixtures are, each one is represented by a container. It's got attributes that the fixture has: pan, tilt, dim, shutter, focus, lens, that kind of stuff. It has an address and a universe, which if you're not familiar with DMX, address and universe is kind of just like how the light knows what data to listen to, right? You send out a universe worth of data, which is 512 bytes, and the light needs to know which of those bytes it is looking at in order to determine where it's panning, where it's tilting, how bright it is, all that kind of stuff. You don't need to know too much about it to understand how this works, but this is the profile of one of our types of fixtures, just in a table. The coarse and fine has to do with the fact that some fixtures allow you to use 16-bit values instead of 8-bit values to control some of their attributes. And so inside of a fixture, we have sort of the parameters of the top level container coming down into here, and the ones that are 16-bit are getting turned into more channels in order to make them 16-bit, and then the ones that are 8-bit just go basically straight through. And then the way that we're kind of pixel mapping DMX fixtures is by taking in the whole texture, which is this guy, turning it back into chop data, and then because there's only one fixture here, it's just turning into one channel, but if there were 4 fixtures, it would be 4 channels, and this fixture would select one of those channels. And then this is where things get this is kind of what I had to figure out, was how to take these parameters and give them names and keep track of them and keep them in the same order while still being able to control them. So this table, where my mouse is all of the channels of the fixture and with all of their names. And then we take the parameters that are just top level parameters, which you would control with like LFOs or something like that if you wanted the lights to pan and tilt, that kind of stuff. Or you would just control them with a knob, for instance, for brightness. And then we kind of inject the color data, right? The color data is here, and we kind of inject it into the right spot. So this is now a chop whose channel is 42 channels, which is the same number of channels as the fixture has. And then take that data and put it into a 512 long universe, and then all of those universes get sent out to the lights. If lights are in the same universe, we just take their universes and just add them to each other. So in order to see kind of what it looks like when there's more fixtures, you have, this is all the color data from the texture turning into 4 fixtures worth of data, and each fixture will select only the appropriate data based on the name of it. So this is BI1, so it's going to select channel 0. This is BI2, so it's going to select channel 1, a little off by 1 naming convention there, but yeah, and then that all gets sent out sort of like this, and you can see that one universe worth of data, when all the fixtures are packed up right next to each other, looks like this. So when you add them together, they don't conflict with each other. There's nothing in place to stop them from conflicting except for me addressing them correctly, but it'll add all those together and ship that out to the DMX out chop. So that's how we do DMX fixtures. And I think, and then we'll move on to the pixel fixtures. So the pixel fixtures is something we've been doing in Touch Designer forever. And we used to do it by way of, if you're familiar with the traditional method of doing it, you basically have, for instance, for these pictures, they're 64 pixels long. You would create like lines that had 64 points in them, and you would merge all of them together into one SOP, and all of those points would represent all of your pixels. That turned out to be way too intense for most of our computers when you have, because we have 22 of these fixtures, which are 8 by 128, and then we have almost 200 of these tubes, so you can imagine with 200 universes worth of data, it gets a little bogged down. So I made this thing that's basically inspired by Resolume Arena, if you've ever used that, where all of the fixtures are these click and drag objects that you can rotate around and do all of that stuff. Their names are based on a convention of every controller for these lights having like different outputs, right? It'll have like 4 outputs that go to the lights. So A 1.1 is the first fixture on the first output of brain A. And I call them brains, but they're LED controllers that use ArtNet to send data to the lights. And it goes down the line, and this is how I would very rapidly, you know, after we've finished placing all the lights and we've got them all powered up, I can very rapidly place all of them in space and rotate them around to kind of sort of match the way they are in reality. Obviously, like, if the lights are in 3 dimensions, it doesn't quite capture that, but there's usually a way to kind of, at parties and stuff, people don't really notice, quite honestly. As long as all the lights are in order and they're not like going backwards, like, and they light up, people are usually pretty happy with that. I do want to do a 3-dimensional, you know, mapping system eventually, but that involves like SDFs and a bunch of stuff that my computer can't really handle. So until I get a better computer and more time, it will be 2-dimensional. So yeah, and inside of this thing is a lot of stuff, but it's actually not nearly as much as you would think. There's a table that defines the different controllers, how many outputs they have, how many fixtures are on each output. I predefine what a fixture is. So in this case, it is a 64 pixel long RGBW fixture. One of the unfortunate things about doing it this way is that I can't mix fixtures of different lengths yet, but I think I have a way of fixing that. That expands out into a bunch more data with like information about the position of the fixtures and their rotation. That gets turned into color data. So, you know, I'm not going to assume too much knowledge in the audience here, but basically we're taking this information about where the fixtures are in SOP space and how they're rotated and just turning that into RGB values, right? So if it's at 0.5, 0.5, 0 rotation, we'll get a pixel that is 0.5 red, 0.5 green, and 0 blue, right? And so that's all these textures are. They look funny, but they're just representations of where the fixtures are in space, basically. We do some math on that that's not super important that has to do with aspect ratio scaling. And then kind of the beating heart of the system and what I spent so long on to try and make sure that this runs on a laptop is the traditional way of doing it asks a lot of the CPU because you end up using a lot of shuffle chops to kind of move the data around in weird ways, and you end up using a lot of top twos and sop twos and stuff, which I do still use, but this kind of eliminates like almost 50% of what we used to have. This is a compute shader that I wrote that basically takes the input texture and the information about where the fixtures are in space, and it will sample the pixels on the correct locations in the image based on where those lines are in space. And then create this texture that's very clean and nice where every row of the fixture simply represents one fixture. And there's a bunch of blank space in there because those are fixtures that I'm like not using, and that's mostly a convention to make the DMX work correctly, but you know, you can imagine that normally it would just be completely full. And then it goes out and the data gets shuffled around and turned into DMX to go out to the lights. So yeah, that's that. So now I kind of want to just go out. This is like what you would see if you were like hired by us as an operator or you were one of us at one of the parties. I spent a long time on this user interface to, you know, add effects to the lights, pick your colors with this nice little render pick, color picker thing, and that kind of stuff. So yeah, this is the whole system that an operator would look at to control the lights. And a lot of the most interesting effects, I think, I've got way too many effects on for you to tell what's going on. So I'll turn the effects off because they make it kind of difficult to see. But this is what Zanzi was talking about as far as having two different generators in kind of like a, you know, two turntables DJ kind of way. So you have a crossfader that will crossfade between the two of them, which is really helpful for making rapid transitions, right? We work mostly with DJs. We have no idea what song they're going to play next. We have no idea how fast it's going to be, that kind of stuff. So you can kind of set up one generator to do what you want it to do if you hear a transition coming, and then just really quickly flip to the other side. My kind of favorite feature is switching the compositing mode of the crossfader to multiply instead of add, so that you can, this is where it really kind of opens up and you can create these effects that have rhythm to them by using a simple generator such as this guy, the sort of outward circle thing, and use it to mask off one of the generators that's more kind of random and like difficult to predict, like this one, which I call Katamari because it's like a big Katamari ball, if you've ever played that video game. But yeah, so that's kind of what we've got going on. I just wanted to go over some stuff that, like, this is very much a work in progress. We've been working on this for almost 3 years now and using it in pretty much all of the events and parties that we do, or for some of the corporate events, I'll end up just taking chunks out of it and putting them in there. So it's very modular. You know, all of the fixtures are kind of their own comp that you can take and move into other projects, and they continue functioning the exact same way. One of the things that I really want to implement, I didn't get the Wi-Fi password, but it's okay, is GDTF integration, which if you're not familiar with GDTF, basically all the lighting console manufacturers got together and agreed that it was ridiculous that they all had different ways of defining DMX fixtures. And so they're all trying to agree on this one way of defining how a moving headlight works and what all of its attributes are called. So I've worked on it a bit, but I would love to finish basically a touch to center comp where you just drop a GDTF profile into it, and it does all the hard work of filling out that table with all the attributes and figuring out like where the color data goes and all that kind of stuff. So that's one thing we want to do. Generalized pixel mapping. I'm not very good at compute shaders, And one thing that would solve the problem of not being able to use different length fixtures would be generalizing the texture to just DMX data rather than, making the texture 64 pixels wide for a 64 pixel fixture. The shader would simply, put the fixtures where they need to go in DMX address space, and then the data would just get spit out as DMX. And then it wouldn't matter whether the fixture had 8 pixels or 1,000 pixels. It would just get placed in there where it needs to go. Improved UI performance. So we use a MIDI controller in addition to the touch controller, and we use binding for that. And one sort of side effect of binding, if you've never used it in Touch Designer, is that Touch Designer doesn't know not to basically update all references of bindings. And in short, what that means is every time you touch a knob on the MIDI controller, it recooks every single user interface element because it doesn't know which ones are changing and which ones aren't. It just updates all of them. And so you'll see if I start moving this knob around, you probably can't see the frame rate window, but it drops to like 40 frames a second while the knob is moving. One way of doing that as well is just moving the user interface to a separate instance of Touch Designer. And then we also, from a more creative aspect, want to add some kind of like drum sequencer kind of effect to mask out the images. So like, in essence, like what you're seeing right now with this generator where the circle is masking out all of the dots, instead having one that sort of performs more traditional lighting chases. So it would like use like blocks or something to sort of create like a BPM tempo kind of effect over the lights. Like right now, the only way to get like proper BPM based effects is to just kind of feel it out with like the circle generator or something like that. Like I can sort of sit here and be like, oh yeah, this seems like it's about the right speed. But yeah, we call it the mask engine, where it would just simply, the simplest version of it would be just flashing the whole texture at some given BPM. But there are a lot more other ideas that we have for that. Did I forget anything?
Oh yeah, I mean the BPM. Generally, when we made this control system, especially working with operators, one of the we intentionally made it so there was no like BPM tap, because a lot of traditional lighting consoles like MA, like it's all based around these BPMs and stuff. And I think like when we were making this, I was like, the idea, it's like if you DJ with CDJs versus like using vinyl, like you can match the numbers up on the CDJs when you like switch from song to song. But something about like using vinyl to DJ, you're forced to like listen to the music. And I think with this control system, especially, we make this software to be able to be used by a bunch of people that might not necessarily know how to use it very well. They can kind of show up and play with it. And we've found that like it produces much better lighting results, and people like tend to use it in a better way by actually ignoring BPM, ignoring rhythm, and forcing them to like look at the lights and make decisions as creatives and as like visual artists, and make sure the vibe is right, instead of like looking at some like number on the screen to be like, oh, this is correct, oh, this is the right beat. But yeah, there's certain ways that like you would control Grand MA, or like, which is like one of the more traditional like lighting consoles that are for concerts and stuff, that if we want to integrate it, we have to integrate some sort of like BPM sort of like cueing system too.
Yeah, and I think that speaks to the fact that this is very much like a working piece of software, not in the sense that it always works, but in the sense that it like makes money, right? Like there are many, many things I would do with this if I did not have to like hand it off to, someone who doesn't know how Touch Designer works and go, okay, you're gonna be here till 8 a.m., right? Like, cool, all right, I have to go to sleep, right? Like that very much like applies some limits on this software that, I would love to have enough time to sort of make a complicated version of it and a simple version of it, but that's always sort of a push and pull of how much sort of touch designer, craziness can I apply to this without people who are possibly less experienced with video synthesis getting completely lost in how it works, right? Like even the multiplier thing is kind of like, I named it add and mult because I know about compositing, but that, I recognize that that's not even necessarily like the most straightforward way of naming that. Same thing with like delay and echo. I've tried to make it as straightforward as possible, but it is a custom video synthesizer that, is used for raves. So it's a pretty weird piece of software that doesn't really have, it has a lot of influences from a lot of other pieces of software, like, obviously music synthesizers, Resolume, all of that kind of stuff, but it's kind of become its own creature in a weird way.
Gumgum's aesthetic is largely like this kind of like battle between me and Andy, where I'm trying to like fit as many lights and make it as chaotic as possible, and Andy's trying to like hold it all together in Touch Designer, make sure the lights turn on and everything's safe. And so it's kind of like bounces back and forth between where like our design choices are largely due to like me like trying to use too many things, and Andy being like, okay, we can do that, but we have to do it this way. So then we wrap the creative around that way, and then we like maximize that on the next version. And the software is developed from that.
It is cool though, because I feel like a lot of the ways that you traditionally pixel map in Touch Designer assume that you know where all the lights are going to be before they go up, and I feel like I never would have made the sort of rapid, moving all the lights around kind of, and like another feature of the pixel mapping that is not in Resolume is that this is the one that's actually running the lights right now. So if I grab one of these lights, it turns white, so that I actually know which one I'm touching, right? So like stuff like that is the kind of thing that you wouldn't do if you didn't have to do this on the fly, right? You would just, know where all the lights are ahead of time, and you have, a whole day set aside to troubleshoot, or even a half a day set aside to troubleshoot, whereas this system really has to kind of rock and roll with, pretty tight schedules and, the chaos of installing illegal raves in warehouses and stuff.
Most of the cool features are due to me ruining Andy's life at some point.
No, I mean, it's a necessary push and pull, I think. But yeah, so I wanted to leave enough time for questions, because I kind of felt like I've been to a lot of these Touch Designer meetups, and I haven't seen a project that was like quite this like intense and had all these different parts. So I wanted to leave a little bit more time if people were interested to ask about the more specific parts of it, if anyone is interested.
Yeah, I'm glad to hear you're struggling with all the same things. I mean, it's like we all have to struggling with these things alone.
Mm.
Yeah, the offset of DMX channels and getting dumb machines to do smart things.
Yeah. Well, thank you. Yeah, no, if you do decide to go down the route of controlling DMX fixtures with Touch Designer, yeah, it's the chops lack like the ability, like they don't have any metadata, right? So it's like you're just kind of having to like deal with all of the DMX channels in this very manual way, and I've used a lot of Python to kind of manage that, right? That's one of the better aspects of Touch Designer, is that I can, get frustrated with something, get frustrated with doing it manually, and then be like, okay, like I can break this problem down into a little bit of Python, and then Python can just do it for me next time. And that's been a huge part of this project, is just like writing a ton of little Python scripts to kind of not even necessarily make the thing look any different, but to make my life as the primary user of the software a lot easier. And I think that kind of is one of the most amazing things about Touch Designer, is that you even can do that. And it's why I don't just like pipe Touch Designer out to Resolume, is because there are a lot of things about Resolume that I don't like, and I can't change them. If I don't like something about the way Touch Designer works, I just make it, which is what keeps me, working on this for 3 years instead of just having two computers with two different softwares on them. which is equally frustrating in its own way, as someone who has gone that route. Yeah, so I'll show you my dirty little trick to basically I have sort of solved the binding problem, but it's really ugly. So what it does is it takes all the MIDI channels and makes a new individual bind chop for each and every one of them, and then binds, like every bind chop is only going to one thing. Because the way I used to do it is I would just take all these are all the MIDI channels here, and I would just stick that in a bind chop and then, bind reference everything out to the UI. And that would cause it to like almost crash with enough channels on a slow enough computer, because it would recook the entire UI. This has bought us enough frames that like you don't really see the frame drops, and that's why I haven't been super pressed to fix it by sort of taking the UI and putting it into a separate touch designer process that doesn't affect the frame rate of the lights. But yeah, so that's my solution. And if touch designer ever makes it so the binding doesn't do that, then I can get rid of all of this. But moving it into another touch designer process is also kind of the right thing to do anyway. So I will eventually do that. Probably like 200 and change, I think. Each one of these fixtures is 6 and change, and we have 22 of them. And then, yeah, with the 200 lights, and then most of our we also chose moving heads that are really big. Like each one of these is 113 channels. Big in terms of the number of channels they have. So yeah, about 200, I would say, is the maximum output. And I've never had any issues with like the DMX out slowing down. I've had like network problems, but they weren't touch designers problems. It was just like cheap network gear that like couldn't understand the amount of UTP traffic.
What was the last party we did had like the fixtures at the very end of the chain?
I don't know what that was. That was not touch designer though. It's always the cheap network switches that I use that cause those problems. But this is not about networking. It's about touch designer. But yeah, so about 200 I would say is, and it shows no signs of slowing down. I'm sure you could go up to probably 300 or 400 as long as your computer and your network card were up to it. The next rave, good question. So we do Dripping, which is a festival out in Sparta, New Jersey. That's in, it's like, the 12th through the 15th of June.
15th,
and then we do a party called Zero Chill, which is a very, very big rave in East New York. We're doing the Pride one at the end of June?
Yeah.
At the end of June, yeah.
We have little things, but those are our 2 big ones.
Those are the 2 big ones, yeah. Last weekend was the last Zero Chill, and that was what you saw. Where is it?
Well, this is the New Year's.
Yeah.
This is the rig of the New Year's one. Yeah. So if you
oh yeah, that was New Year's. Yeah. So New Year's is right here. It was about 40 something feet long, with somewhere close to 100 tubes on it. And then this is the upstairs, which is like a dilapidated office full of a bunch of moving heads and stuff.
We stick everything up above the like drop ceiling. It's
we destroy their drop ceiling and put all of our lights up in there. But yeah, you can see like, we don't like do Vectorworks for all of this stuff. It's like we just kind of show up and do it. Like we have a plan, but the plan doesn't necessarily involve exactly where the lights are or what their addresses are. So all of that is kind of figured out on the fly.
And generally with lighting design, we try to make like we like want to shift towards like considering like almost like sculptural work. So we're not trying to be like lighting vendors where like, oh, like someone hires us and we point the lights, like distribute the lights in this way. It's really about creating these like packed, like really jam-packed, detailed, like dense structures that kind of like run all together. Because Andy doesn't like it when I has to spread the lights all over the place. It takes so much labor.
Yeah.
But then also, it just creates this. We'd rather someone like look at the light and not think of like, oh, that's a moving headlight. Oh, that's a pixel. That's a line, and really just like have it be like, what the fuck is that? So
Yeah.
like, a lot of what we do is create these dense structures. We put like fog tubes through them, so they have their own atmospherics inside of them. We're trying to create these kind of like machines. And yeah, this is what plays over it. Yeah.
Cool. So I think our time is pretty much up, but I've been told that maybe some of the AV performances are interested in having the lights, so we might turn them back on for that. In the meantime, I mean, I don't. Who's going up next? Do they want the lights on or off, or I don't know. I'm just gonna leave them off just to be safe. Let's go off. Yeah, exactly. Yeah.
Thank you.
Let me just.
So, we're gonna take like a super quick break. If you want to grab a drink or a shirt or we have also stickers and bananas, movie file-ins. But we're gonna start the next one in 5 minutes. This is not a long break. Yeah. That is. It's in the way. If you want. That's great. Yeah. Very, very. Richard.
Try just playing like Spotify on your computer. Are you playing Spotify? Or iTunes, yeah, whatever. I'm gonna start to increase the volume.
There we go. Ooh. Ooh. All right, we're gonna get started with Andre here. 2-minute warning.
Okay. I'm ready. Test.
All right, if you could start making your way back in, Andre's going to be starting in just a second here.
Testing.
All right, could y'all please put your hands together for Andre? Thank you.
All right.
Switch this over real quick for you.
Let's switch over the video signal.
Quick little. All right.
Yep.
All right, take it away.
Hello, everyone. My name is Andre Lira, and unfortunately, I'm just one person and not a creative studio, so temper your expectations with this talk. I'm going to be talking about how I built this installation here in front of you, which is called Hovercraft. It is my master's thesis for NYU's ITP program. If you know ITP, give me a signal. There we go. All right, let's get into it. So just a little brief bit about my background. I mainly, in the past, 15, 20 years or so, I've been making music under the artist alias Dr. Jeep. I make electronic dance music. And for the past 10 years, from 2012 to 2023, I was working full-time as a senior producer, like project manager at a bunch of music and audio creative agencies. And, at some point towards the end of that, I was getting kind of tired of just like working and just like these logistical, administrative type jobs, and I wanted to do something more creative. So I took the jump and started grad school kind of late in my life. I'm 35. And around 2020, when the pandemic hit, being a music producer and when the clubs are all closed because of the pandemic, I didn't really feel super like motivated or incentivized to like make music. And I discovered Touch Designer and kind of from there became obsessed with it. And so ever since then, I've been making these sort of audio-visual installations to kind of bridge the gap between, my love for music and love for just visuals and lights and art. And so some of the things I primarily focus on are like audio reactive installations, ones in which I'm creating audio for my installation. And so I'm just gonna give a quick, brief rundown of several things I've done. These are all very short videos. This is an instrument I made last year called the pitch rail. And in this instrument, the instrument itself is not made with Touch Designer, but I'm using the visuals, getting the MIDI from Ableton as I'm playing it to kind of just showcase to the audience like what is being played. This is like an abstract representation of the 12 notes of a chromatic scale. And so as I'm playing it, you're kind of imagining this kind of piano in midair being played. Next, I have an installation called Sonoluminescence, which it visualizes the notes you're playing. So someone is playing notes on a keyboard, and these kind of vertical beams of light are displaying those same notes, much in the same fashion as the last thing, but this kind of brings it more to a concrete reality, having these lights right in front of you. I also really like sending MIDI from from Touch Designer. And so some things I do are creating these sort of interfaces in midair for making your own sort of. Could you make a piano where you can place the notes anywhere you want? So this is an example of that. Not played very well, but you get the gist. And so in this case, I can also make a chord in midair. All right, so you get the point. I love MediaPipe. Thank you, Torn and Dom, for changing my life. This next piece is one in which I took an image of my face and I wanted to sonify it, and so I basically created a system in which it takes the pixels of a grayscale image of my face and kind of plays it in real time in Ableton, so it looks like this. As you play with the kind of coloring of these pixels, it's obviously changing things like the velocity and the volume of it. So this is an abstract kind of weird thing. I make all these little ditties for Instagram that I really enjoy posting. I was inspired by another artist who I saw do this with a live video feed of them, and they were using Max for Live, which is honestly a bit beyond my comprehension. So using Touch Designer to be how can I emulate this in a way that makes sense here was a very fun project. I also just aside from music stuff, just controlling lights in various ways. So this is a project in which you approach this kind of box, and as you would do a gesture, in this case a scream, it kind of creates this rage box sort of scenario. So these are very simple projects. I'm in grad school. We have a week to do this stuff. So obviously it's not these kind of 3-year-long insane Touch Designer projects. So like I said, bear with me. This is a project in which I created this little game where you're a monkey kind of trying to get down to the ground. And this is a projection mapped image from Touch Designer in conjunction with these LED bars. So that sort of interplay of the projection and the LEDs is fun. And lastly, this is a MIDI reactive, and it's freezing. Let's try this again. MIDI reactive projection mapping using one of my tracks. So, I get the stems from Ableton and have those influence different parameters of the projection mapping, right? So as the bass is sort of wobbling, this kind of green thing is kind of pulsing in and out. So I really like this kind of thing, especially with live AV sets. When the music and the visuals are totally in sync, it creates a better experience, right? So having said all that, I want to get into my project called Hovercraft, which is this thing right here. And essentially what it is an interactive installation. Let's pause that. Where basically you can hover your hands over this and it creates this lighting and these sounds. And the idea is that I want to democratize the music making process. And so imagine if you're a 5-year-old child, right? And you see a grand piano in front of you. What's your first inclination? Probably to go like, ba 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 ba. And it's going to sound like crap, and you're going to be like, making music sucks, I hate this, I'm never learning piano, right? But if you gave a child a interface where no matter what they did, it sounded good, that just gives them that dopamine rush of like, okay, I enjoy the act of making music, and therefore I might struggle through the early parts of trying to learn this instrument, right? So I'm not going to play this video, I'm just going to give a quick live demo of what this is. And to help me with that, I will demonstrate here what is going on. So hopefully, I don't like do this in dark lighting conditions, so like let's see if this works, but you see my hands, right? Let's bring this over. Woo! Okay, so you see my hands. The tips of my index fingers are controlling this interface, and as long as they are within the boundaries of these white pucks, it plays sounds. So if I played, right? That's a standard sort of like minor scale played by a xylophone. I don't know if you can really see this in this video, but they're essentially things you can control here. So the instrument, it's a grand piano, a flute, strings, xylophone. Scales, so like major, minor, harmonic minor, and Phrygian, which is sort of like a more exotic scale. Is it playing a single note or a chord? Is it playing a single note or arpeggio? So let's say I want to play a arpeggio, right? I can hover my hand over this little icon. It'll flash, and now, right? I mean, there's nothing I can really do that's going to make it sound like out of key or bad because it's all locked to that scale. So let's try a different scenario, right? Let's try like an instant Beethoven sort of vibe. So I will change this to the strings, and I'll change to a different scale and to the chords. Something like that. So basically, like, I'm just totally freestyling here, and it sounds like I have actual music skill and experience. So that's the idea, right? Like, you can have no musical ability and come here and just kind of like mess around on it and be like, wow, this is great. I feel like very accomplished. And so moving back over here, I will explain this and kind of what's going into this and how Touch Designer kind of helped me build this. So let's go back to the slideshow. And let's skip that. So yeah, there's these 4 different kind of controllable parameters: instrument, scale, chord, and arpeggio. And I didn't really want to overload the user with like different options because the more these kind of changeable things you can add, it just can be a bit much, right? So in this case, it's like you really have like 60 possible combinations, like 4 times 4 times 2 times 2. And I think it's like a good amount for a school project essentially. I mean, this is my thesis, but it's like I'm not selling this yet. I would like to at some point if I get an investor. Anyone? But yeah, basically the way it works is that there's a standard, $20 Amazon webcam that's looking down and it's using MediaPipe to track my fingers. And so when it's doing that, it's doing 2 things simultaneously. It's sending MIDI data to Ableton Live to, play the notes and also kind of change the various parameters that are happening, kind of turning on different effects or turning off different effects. And at the same time, it's sending a video to MadMapper, which is mapping it on all these LEDs. And I'll do a live kind of in Touch Designer demo in a second, so bear with me. So basically, when I'm sending MIDI notes to Ableton, I don't know how many of you are familiar with this, but there's like a nice little component called TD Ableton where you can do things like write a single line of Python, and then when you do something, it sends a note, right? So in this case, as you can see, like when I'm hovering my fingers over those things, it's sending different MIDI notes. And each one of these is a chop execute that's saying, OP Ableton MIDI dot send note, 62, which is the note C, I think, or maybe 64. And in addition to that, there's also these different lighting changes. So actually, I'm just going to do this in the software because I think it's a bit more engaging. So if we scroll down here, my network is not as organized as everyone else's because I have a chaotic brain, but let's take a look at this, right? So this sort of like very low resolution image is the current state of the instrument LED, right? So if I, okay, let's do this. If I walk over here and I hover over here, you can see that this is kind of changing, kind of like going through the motions of switching the instruments. And I do that for all of the parameters and then kind of compile it into one master shitty low resolution picture, which it is sending to a MadMapper with a feature called Siphon, or Spout, I guess. And if you don't know what this is a sort of communication protocol that allows you to send video data between different softwares. So for example, if I look at MadMapper, this is the mapping for my 8x32 little LED panel that's kind of inside this. And come on, extend. So as I change things, all of these vertical, like the rows are the different kind of like rows of LEDs and the columns of LEDs. So as I change this, well, I hid this, which is important, but right. As you can see, it's kind of just making these like little changes that are kind of reflected on here. And in addition to that, there's this whole system of like, let me send, pulses of light as I play these notes. So I have this like arrangement here of different components of LEDs, one for each color, the colors of the rainbow, because I am unimaginative. And they all go into this layout here. So as I play different notes, you're going to see different kind of like rows of colors happening. So right, and I wanted to make it so that the lights and the sound are kind of related in some way. So for a single note, it's a full bar of light. If I change it to a chord, which is 3 notes on top of each other, I wanted to make it kind of representative of chords. That looks like this. Same thing for like an arpeggio, that's like 3 notes in a row. So to me, that looks a bit like this. Etc. So, when thinking about like building these sort of like physical installations, I want to think about like how can I make this the most engaging for an audience member, and also the kind of most like dopamine stimulating, and kind of like, okay, this all fits together in the same universe, which I really try to do here. What's next? Right. So then thinking about also like, whenever you see this media pipe stuff on Instagram, it's always someone in front of the computer going like this and like changing a little visual. That's really cool, but that's only that person interacting with it, right? With something like this, I have to consider that there are people that I don't know at all using this, and like it might be installed somewhere where it's not very visible. In this case, it actually wasn't a great location right there at the end of the staircase, but it actually kind of blended in a bit with the kind of surroundings. So I made this pulsing sort of like idle state that basically says when someone hasn't touched this within 20 seconds, switch to this new light pattern, and the moment I touch it again, it goes off. And so in about I think the last time I set this timer, it was for 30 seconds. Yeah, in about 30 seconds, it's going to go back to that thing. So yeah, thinking about that, like how do you invite users to come and touch this, right? Because if it's all dark, no one's going to know that this is a thing you can interact with at all. But if it has that pulsing light, it's like, oh, it's this. I'm going to go investigate that. So that's like one kind of component that I thought of in terms of like how does this differentiate like standard sort of like interactive media art with things that people actually do interact with in real life. Secondarily, basically what's happening here is that as my fingers are hovering over these 3D objects, in Touch Designer, 3D objects are in this kind of XYZ space. But when you're looking at a video, like a kind of 2D top, it's in the UV space. So I have to figure out a way of converting those 3D coordinates into UV coordinates. And so I basically had a system going where I did some mathematical calculations and was able to like actually map the UV boundaries of each one of those elements. And so I can move them around, and then no matter where I move them around, it's going to have the same effect. So it looks something like this. If you could like notice over here, the UV boundaries are moving as I move this 3D kind of like semicircle over. And that's really helpful because now when I guess there's no sound here, but as I'm playing those, it's still playing the same note, but can be in totally different positions. So that allows me to do a lot of user testing where I'm like, making the circles bigger or smaller, like rearranging them. Originally it was in a circle, now it's in a semicircle. And it made it so that I didn't have to like manually be like, all right, what are the boundaries of this thing? Previously, my installation looked a lot different. It was this like giant 40-inch TV with this like big LED panel, and a lot of the graphics are more like 3D, so these spheres instead of these little pucks. So having that sort of like 3D to UV converter was super helpful in that case, because that way I could really play around with like, do I want a sphere? Do I want a cube? Do I want a so-and-so? And not having to like rethink how I'm positioning this stuff and how I'm going to interact with that. Secondly, so the way this is made is basically there's many layers of laser cut wood here. There's 6 of them, and at the very top there's a nice kind of like sleek black acrylic. And as I was cutting these, these layers sort of look like this. And if I open up Illustrator to illustrate this point, it looks like this, right? This is the top layer, this is the second layer. The pucks with the LEDs kind of fit in here. There's room here for different wirings and cables, which it looks kind of weird, but it allows for like me to have all these wires without it interfering with the actual build device, and then more, and then more, and then more, right? So if I ever wanted to see like, will this component fit inside here, what I would normally have to do is take all of these and just align them together. And if I look at this now, I can't see what the hell is going on here, like, especially if there's no colors. And then I'm like, okay, I have no idea like which case, in what orientation these things have to be. And like, there might be a scenario where I cut something and then actually like is overlapping with something else that I wasn't expecting. So what I did was I basically created this Tox where I could like import these files automatically. It would create a 3D geometry of it. It would extrude it to the right thickness. And then I could use MediaPipe to kind of play around and explode it in midair. So this is what I made. And it looks like this. And basically it allows me to like create this 3D model of this, which I've never seen in Touch Designer, and I just don't know how to use Blender or like Fusion 360 or anything. So one day I woke up at 6 a.m., had to pee really bad, and I was like, I'm just gonna stay awake. And I just built this in like an hour, and I was like, oh, actually this is really helpful, because in that process of like exploding this out, I can identify certain kind of pain points in my project. So this is like a way I thought of like, how do you use Touch Designer for these like unconventional ways where it can help you with things that's not really meant to do. I mean, if anyone else does stuff like this, I would love to know, because I would love to know some efficiencies there. And I had the project open, but then in the process of moving all this stuff, some cables got knocked out, and I had to like quit Touch Designer and stuff. So I'll open it at the end if I have time. Actually, I have no idea how much time I have left. Okay, like 5 minutes. But essentially what it is a series of replicated components that get their name and also the contents from this like file folder. So what happens is that if I save one of these files as like left 1, it knows to basically put that 3D geometry on the top level, extrude it 0.25 inches, put it on the left versus the right, obviously. If I do left 2, it makes it automatically under it. So then in that case, when I have all these ready, if I want to make any change, I just go to Illustrator, export left 1, replace the file, and it just automatically changes to that version. So it's not like I'm manually kind of like re-uploading files, which is quite nice. Yeah, I mean, like I took a few screenshots here just in case it didn't work, which is the case. But basically, inside of each of these components is a geometry that has its value on the z-axis kind of like automatically offset by whatever number its name is, which is the file name. So it creates this system in which, as long as I name the files correctly, then it just makes it automatically, which is very convenient. And I also did this depth calculator, which I feel like an idiot because I just realized this is actually a feature that you can do in MediaPipe. But I had this stroke of genius where I was like, all right, I want to be able to do this thing where like I do, height mapping on this, right? Where if I'm like lower might be a higher volume, higher might be a lower volume. And so I spent some time looking into these like math equations that I guess is already incorporated in this with the hand distance thing. I just didn't see that, so I tried to make it myself, which I did, which is great. But the problem here is that as you get closer, farther from the camera, it works in the exact center. But if you're on the edges here, I am going just straight forward towards the camera, and it appears to the camera that my hand is kind of going off to the side. So what ended up happening when I was testing this is that, like as I'm going up, it kind of like actually leaves the boundary of the circle and therefore it doesn't play the note. So I kind of gave up on that, but I just like this depth calculator anyway. I'm sure that the version that's natively built into MediaPipe is probably better, but so be it. It's just one of those things where it's like, do you have a problem? There's probably some way to fix it, or not fix it, to like solve that in Touch Designer. And if you can figure it out, then great, love that. And just to finish off here, one funny thing I discovered was that as I had this sort of like TV version of the installation, which I showed at my school's winter show, the camera is facing down, and it doesn't really matter what is on there. What the kind of UI on the screen helps in the sense that like you can tell where to put your fingers, but you really don't need that. And as I was testing this, I just kind of put on a random YouTube video of this guy doing like ASMR hypnosis with his hands, and it was actually tracking that. And so in MediaPipe, it's like looking at his hands, and he's accidentally triggering these things. So it's kind of like you can use these videos as like sort of like, oh, free generative art, like just get any videos of hands over this, and then you're just kind of randomly touching stuff, and it's like, oh, cool, I didn't know that could work like that. But yeah, that is essentially my talk, and I'm going to open it up to questions, but also just leave this here because, listen, I need a job after I graduate, and if anyone is interested or thinks I'm smart, please contact me on any one of these very convenient QR codes you can scan, and it goes to these things. So on that note, I'm going to leave this here, but are there any questions about this interface or my practice or anything like that? And I can't really see, so if you are raising your hand, just yell it out. No. Listen, I mean, it's really more like a toy than a legitimate musical instrument. I'm going to be totally real with you. There's only so much you can do with it. You can make a 1-minute piece that sounds great, but like any more than that, you have to like change instruments, and there's a kind of like a silence. I would like to fix that at some point, and I had this whole grand vision of like, all right, you can hit record and then record your thing, and it's going to email you this file and all that jazz. But then it just became too much of a chaotic process, and I wanted to focus more on the kind of like nice fabrication of it. So the answer is no. Not yet. Yeah, there we go. I did not. I did a 1-credit weekend course on motion graphics, which is where I built these things as part of a homework assignment. But basically, yeah, like you'll kind of notice if I turn off, where is the layout here? Let me just exit this. So you'll kind of notice on the left here, like the arpeggio and the chord mode. If I hit those, it kind of does a nice little animation. So behold. I am not a designer or animator, so this actually took a long time to make. And if anyone wants to help out with like doing that for me in some capacity, I will pay you money to do that. Okay. If there are no more questions, then thank you very much, and enjoy the next step.
Next up, we've got Luis doing a quick little break, and then yeah, Luis Lascelles, wherever you are.
You're plugged in for audio. You got audio plugged in? Beautiful. That's okay. That's okay. Dancing soon. Beautiful, yes. Or turn you out. Move the table. Yeah, let me. I'll check your video. You sending me a blast? Yeah. Are you playing or no? Is that you? Oh. Sounds like we've got something. All right, yeah, no. A quick note on the shirts. We might not have all the sizes at this point, but we have like talked with the shirt company. They held the screen for us. So if anyone's gonna like know they're gonna be back at the next meetup, we can place an order with your size and we'll have it ready for you to grab at meetup 9. So, also the shirts were designed in pops. And in Touch Designer with pops. Inside of pops.
Hello, hello. Great.
You all set?
I think so. Let me just do this too. hello, hello. Make it taller. I'm so short. Yeah, that's fine. Hello, hello. Oh. Hello.
All right. Next up, Luis is going to be doing a little background on some Touch Designer, Unreal integration, and also with some projection mapping and maybe a little Mad Mapper action. But Luis has been doing some really, really amazing work in the media art space, and we're so excited to have her here tonight. So could you please give a huge round of applause to Luis?
Hello, everyone. All right, we are running with this presenter view today, so I can click around between different things. And yeah, I am Danish. I am New York based. I work with a ton of different agencies, and I am the kind of person who gets brought into a project when everything is on fire and it needs to happen fast, and like, what's the quick plug way to fix this? And when I'm not doing that, I also VJ and do custom lighting installations. A bit like what Gum is doing now is what I used to do back when I lived in Denmark. My tools of the trade are Touch Designer mainly, Unreal Engine, used to be Unity. My full computer science degree was taught in Unity, so it's hard to fully go away from, but I am mainly an Unreal Engine convert. And yeah, I work with these lovely companies. And without further ado, let's dive into it. Oh, and I am ITP. Anyone in the audience? I'm sure there's a few. Yeah, so currently what I'm actually doing is I'm doing some research down at NYU Tandon at the Yard, playing with all of our tools and figuring out pipeline research and teaching class in projection mapping and Touch Designer. So like right now I'm diving into volumetric displays and volcap a bunch, but I just finished a big project on image-based lighting integration for our for our wall cap and also for our LED wall. But we got a bit of everything, so swing by. Like we're kind of like trying to get more community engagement, so that's an invitation. Please come see me. This is some of the work that I did while I was at ITP, and it kind of describes quite well who I am as an artist. I love working with tracking-based media. So I work only real-time. That's kind of I'm a creative technologist who specializes in real-time. Because you can be anything as a creative technologist, right? Like, it's literally a tool of everything. So this was Unreal. This was a performance doing DMX mapping of brainwaves live to audio for this performer, Hayden Thorpe, who used to play in a band called Wild Beasts that I used to listen to so much before they unfortunately split up. But yeah, so another ITP project actually. And my laser harp project that listens to satellite data and changes the sound based on how much trash is floating by overhead right now. So yeah, if it's nerdy and something can be plugged into something else and something talks to different programs and it's basically this whole chain of things, I'm into it. And so this is where I came from. This is what I did in Denmark. I worked for Vertigo while I studied undergrad for a while, doing these big stage shows and big interactive 40-gate stereo mapped sound. Sort of every single one of these gates interact to the audience when they walk through with movement sensors and sense waves through, hence the name The Wave. And then building mapping. So I just kind of, when I landed in America, kind of just continued that vein and started working a bunch in collaboration with Candy Stations, who does visuals for St. Vincent's, Ken Stevens. You can kind of tell I grew up in the music business probably. And I do these really custom things that's like, oh, we gotta get all of these animals quick to do this like totem pole, and can we just like cut off the butts real quick? So we don't have to like throw them into the whole pipeline of actually remodeling them and like redoing the animations. And so like I'm really good at cutting those kinds of corners. So here's like all of the many layers of cut off shaders that I wrote. Yeah, and so same idea, different, also touch designer. And I actually gave a talk with the touch designer team with the derivative for a while ago about this, which is FBX mapping and then making it sort of look like stars, but still vertex based, because we love the look of, it can't be too pretty. Gotta have the nitty gritty in there. But the main thing that I'm super obsessed with is like live performance, interactive visuals. So that's kind of what I'm trying to perpetuate in my own work here with 2 performers. This is actually in processing and P5, 1 layer in P5 and 1 layer in processing. Basically, the idea is that they draw an interface with their movements, and then there's a post-processing shader that does fluid simulation. And so I'm like really obsessed with these types of tools. And as you can probably tell, it doesn't really matter whether it's Touch Designer or something else. But at this point, it's pretty much just Touch Designer. And so I was lucky enough to work with an agency a bunch called Dayan, and like taking this to the real life. And we did here for YouTube Brandcast, we did Doja Cat. That was super fun. Of course, we did everything Touch Designer. And then they were like, can you do it Notch? And we were like, oh, no. But we managed and got everything done. But these types of agency projects are fun because they're super crunch, right? Like, it's like a month to do all the visuals. Where usually I have like a whole year when I work on my own stuff. This is some of my own stuff with my artist studio slash artist duo that I have with Nina Francisca in Denmark, where we do band visuals. So we use Unreal Engine and Touch Designer primarily, and work with a bunch of mainly artists that are doing like 360 sound and trying to push the boundaries for like what a concert can look like when it's not just them on a stage. But the main topic that I want to talk to you about today is all of the prep work that goes into all of these sorts of things. So like, let's dive into just some of my slides from the NYU stuff. So whenever we're doing all this stuff, like you can't get around pixel maps. We already saw it in Gum Gum. Like the idea is that you have some map that you're mapping either projection or LEDs or whatever to, right? And we have all of these like different resolutions. And even if we don't work with pixel maps, we have this concept at least. And so when we're working on these big, gigantic things, it's like, oh, this is a 16K image. Can you do something with it real quick? And there's no such thing as real quick when it comes to a 16K image. So that's kind of where I come in. And so the idea of a pixel map is everything has it. It's the amount of pixels across like an LED screen for a tile, for instance. And I think you can generate them from whatever tool. I think Matt did such a wonderful job last time he spoke explaining it, but here's a wonderful pixel map from his talk, where you're mapping all of these different surfaces, whether it's for projections or LEDs. You have this map, then you have these wonderful like ranged, named surfaces that you then send content to, right? So in my class, I try to perpetuate this idea that whether you're using Can10 map or Mat map or whatever, you need to understand that geometry is something that can be UV wrapped. That's like the main first concept. You need to understand that different materials cast light differently. It's really important for previs. And you need to understand that like the idea of a UV and like the color space from 0 to 1. So like here we have like 0, right? Here we have 1 defined by green. Here we have 1 defined by red. And then 1 and 1 gives yellow, right? Red and green. So those are the main concepts. In Touch Designer, we're very familiar with that. It looks like this. And so when we are using Kantan Mapper or something like that, what we're essentially drawing and what you get pulled out of that second input is essentially differently colored here, but it's a little pixel map, a little 0 to 1 space. And then you're assigning content to that, right? So what's really important is that you have a good concept of that and you have an easy way to know that you've mapped something correctly. So this is my favorite, like, very generic pixel map that I use for everything, because it works great, because I'm not colorblind. I've worked with colorblind people. It don't work so great. They literally had to be like, no, put something else on. But so I give this kind of test bed to my students that's like, okay, like, you see how it gets stretched when you just assign something that's supposed to be square. If it's a pixel map, if it's LEDs, like, they're supposed to be square. And then I give them this projector that is out of frame here, but that is able to project images as light. And then we actually take in LiDAR data and then try to map it as sort of like, we're not ready to go on site yet, but you need to understand that there are different layers that get mapped differently when you're working with light. And it's nice to work with a tool like Unreal Engine, because it's free, that they can go in. So I actually give them the LiDAR model, they project the model of the building back onto the building, and then they map it live from Touch Designer. The quick demo that I did today for this is based on this project that I spoke about, like, at the very first meetup. But this is a project that we did with Uberat for a band named Glass. And the idea with this is, what we're trying to perpetuate in Uberat is the idea, Uberat means untouched nature, by the way, in Danish. It's like the idea that something is wild, but you're trying to tame it, or maybe not. But it's the idea that we give this sort of interface to the band, similar to Gum Gum, where we can walk away from it. Like, we give them a laptop and they can click some things and it's already integrated with OSC and whatnot to, like, their Ableton. We walk away, we don't go on tour. So that's kind of the idea that we try to perpetuate. And we're quite obsessed with, like, getting whatever the band wants, but getting this like smoke here in the back is Touch Designer. And these light rays are also Touch Designer, and this is just a regular LED screen, or not LED screen, projection screen. So we're quite obsessed with this, like, idea of, like, hyper real nature, but that's also kind of plasticky. Oh, and I should just say that one of the tools that I'm about to show is on my Patreon that I just started. But if you find it useful, I think it's basically a glorified, like, crop tool. But a lot of what I do is, like, glorified cropping. So I think you'll probably find it useful. But basically, this Glass project, which looks a little bit like this. Let's see if I can get some audio. So this is a project that we did with the band, and then we did a 5-day residency trying to get all these visuals made with the band. It's interactive, using a Kinect, so you see some water ripples that are reacting to the band live. And I turn down the volume a little bit. Essentially, this kind of project I do all the time, and shout out to lots of wonderful tutorials that I would not have been able to pull off this entire album of visuals in, like, 14 days without standing on the wonderful tutorial, what's it called? Shoulders of Giants, I believe. So this is what it looks like live, by the way. We got this sort of drawing from one of the bandmates. She's an architect. I'm gonna turn it a bit more down. And they're like, these wonderful surfaces that we want to build are going to be this big, but they could be any size in the future. So we need something that's, like, fully mappable, but fully changeable over the next period of time. So this is from a residency that we did. We had 5 days together in this place called Vega Lab in Denmark. Just hunkering down like this, the brain bar. And what we do usually, we'll show up with pre-residency patch that looks pretty clean. Then after the residency, it'll look a little bit like something like this. And then it gets cleaned up again and broken out into these controllable panels that they then get. And we work off of mood boarding, obviously, with the bands. And then this is all in Danish, but we try to get them to kind of choose a song order so that maybe there's some transitions that are always going to be there. It did not really succeed with this band because they really wanted so many different things, but you'll see in a second that the way that we work is really differently mapping different abilities. So we work a lot with, you've heard so much about tool building today. Everything is a tool. This thing does so many different looks. So if I were to go and like 2 hearts, shout out to Paula on this one. This is another moon look that's sort of like meant to be in the beginning of the concert with this very like moody, dark vibe. And basically all of these are these gigantic tools that I extend and then extend and extend together with Nina until we love it. Feedback Edge is my favorite, shout out whoever built that. And then we usually end up with a bunch of different ways to comp things that we can then switch between on, and then we bring that to the band and we kind of go, what do you like? And then we move these parameters together and kind of make some presets from that. So that's how you make visuals in 5 days for an entire album. 14 days of prep, 5 days on side with the band. So yeah, and you have all of the same kind of things that we've already talked about all day. But what I wanted to show is that my latest sort of work and research has very much gone into building this mapping tool that it's just a glorified cropper. Like it allows me to over and under sample a certain pictures is a 4K image that we're generating for the entire patch, and it just allows me to like set a sample point because these moving things that they have for their performance will always be in a new point, and this needs to be something that's easy enough for the band to manage. So like, okay, projector 1, projector 2, do we want to move it a little bit to the side? And then secondarily, we mask it. So we have a masking tool that we work with that are based on David Brown's lovely work. And then in the case of this, I'm going to turn off the speaker out again. Let this run. Let's put on something that has more info. So we'll put on this. This one is like reacting to their vocals, so the stronger they sing, like the more they push this fluid sim out. They were obsessed with that idea, so. So what I do with my students and what we also do with the bands is kind of like send over this as NDI and kind of like do some previs and like understanding of the band of what that might look like on different kinds of stages and whatnot. I only had like an hour to set this exact example up, so there's only one mapped currently. But the idea is basically that if I get my mouse back, F1, that we have our live mapping here, and if I just move Touch Designer down, like I can actually, map this live. And so this is kind of the flow that I work with the students. And also with the band to kind of understand that if they place the projector there or they place this thing in front of that thing, shadows will happen. So, I mean, it's not arbitrary. That is something that sometimes they need kind of like to see. Anyway, I will turn this off for now. and just jump back to, like I said, this just like one projector, quick cropping tool, because it's easy math is online for you to have. So my usual thing where I'm brought in is like, I will do previs in Touch Designer. So you probably noticed that we have this previs over here, and in the case of this project, I'll turn it back on. The idea was that we might put these in all kinds of different arrangements. But when we're mapping this, we're kind of just putting the UV map on, and like when it gets to bigger productions, seeing it with real light and in real environment and with an audience and all this stuff is where Unreal Engine begins to really come in. And shout out to Touch Engine, it's amazing. So here is something I did for League of Legends at Dayan. So this right here is so many different surfaces. This right here is a projection emulating gobo lights. This was some previs that needed to happen fast, like super fast, with a huge team of like 16 people working on visuals and lighting and everything, like all the time, round the clock. This is for the Linkin Park portion. We use Unreal Engine also because, you know, like you need some stuff like fire, stuff like that. And then in the end here you have the trophy coming up out of the floor and whatnot. So you kind of get the idea. But this kind of workflow, why not just do in Touch Designer? Why do it in Unreal Engine? Why aren't you doing it in Disguise? When the final thing is going to be operated in Disguise. Because sometimes the Disguise operator is not on there yet and is not working on the show. And you need quick previs and you need a quick way to split out these kinds of screens. So essentially, these are all of the talks as US assets that were made for this project. So each portion of the stage, there were so many LED screens on the stage, had its own comp here that are then able to actually cut out the map. Why do that? Why not just have the render people who are rendering around the clock already render extra things? Well, if you just look at this screen in the back, it's like so many individual extra screens. So this kind of way I'm able to quickly just ingest the one video that they're making and then put it into Touch Designer and then just like cut it up and previs it live. And then when we're ready to do an actual render, hit the talks, hit render in Unreal, and then I can spit out. This is what it'll look like from this camera angle. So as you can probably see, we have some different levels here. So I made another glorified crop tool, which basically keeps some and passes some on, and then just a very simple like set screen resolutions for each of them, for they might change, right? Like, so really keeping it in a way where it's completely flexible until the very last moment. That's like how I work. Like when you build your tools that way, you'll be happier later. So for this specific one, this was the pixel resolution of each of the inputs. They were still trying to decide whether or not this front screen here, gate, was also going to be part of this pixel map or not when we're setting up. So yeah, keep it flexible. This is all that tool does. Use this, leave this, pass it on to the next one. And so essentially, you'll receive some kind of project that's like from an architecture studio or from something, and it's not pixel mapped, and it's not UV mapped, and it's not anything. And you have like a day to turn the whole thing around into a fully projection mapped stage. And oh, and if you can also turn on all the DMX lights, that'd be great. So here's a quick shot of what that looks like as part of the work process using my favorite pixel map. And huge shout out to Lily who works there because she was the one sitting nights and days doing all the finalizations and fire and such. Yeah, I think I think I cut into everything, and obviously we can dive further into this if there are questions, but since I already talked a bit about it on another talk, I cut it short on this one. But yeah. Yes.
Can you talk a little bit about the difference between using like the Touch Engine plugin versus OSC and like NDI or Spout or like these other pros and cons, I guess?
So, pros and cons. I mean, so many. So, for this particular project, the idea is like NDI I used to get quickly going, right? And then when we get into, but we have to make sure that so the reason that we use this and cut it up in Touch Designer is that I'm absolutely sure there's no extra render time for like spitting out screen number 1, screen number 2, I hope that's clear. Then we use the sequencer and Unreal Engine to start the talks so that the talks would start all of them at the same time. We actually ran into some problems there of not all the talks is like initializing exactly at the same time. But it's great still for like quick previs, quick turnaround, all of that, because all we have to do is like put in the latest version of the talks or like export as talks again. And then when we are ready to like, this is final, this is locked, this is what the show is gonna look like, dear Disguise programmer, make it look like this. We can actually feed them a video that's shot, and at that point we could do a render out and then just drop all the videos into Unreal. But if I had to do that, we received new videos from all of the different, we did 3 different acts. If I had to do that, I would be drag and dropping, not one file, right, or like 8 files. I'd be drag and dropping like 64 files, like 10 times a day. With like the team of people who are working on different parts here. So like that is why you build up a system that is flexible enough. Also, this whole previous was 2 weeks of work and then 2 weeks of like fine tuning. So 2 weeks to set up everything, 2 weeks of like, can we make the fire go a little higher? Can we put more fire there? Could the dancers move into the center? And all that was Lily, because I was off doing a Broadway, please vote for Harris and go door bank. Which, yeah, kind of, we tried. But also in Touch Designer, actually. So I had to build a fully, like, queue system, Broadway mapping theater thing, which I haven't really done in America before. And it turns out you guys queue a little differently than we do in Denmark, so that was fun. Yeah, so shout out to Lily, honestly. Yeah, anything else? I can hardly see you guys.
So you mentioned that the video that gets projected is rendered by Unreal in the end, and what is this trying to do with the mapping of that?
Yeah, so throughout the whole thing, Touch Designer is cutting up everything for us. So like basically this cascade thing. So every time I have to do something, I just drop in another version of, you know, a movie file in from, and so in the end, we actually didn't even we ended up using Touch Designer all the way to the end, because we found out that just putting in some pre-render frames, like starting it early enough, then they kind of began to start at the same time. But you can't just like, the talks take time to initialize. I don't know if that's still the case. This is a little while ago. So we just pressed render, and it is in sync. If you wanted it fully correct, I would put the movie files into like I would get the final team to export all 64 videos. I don't think I've but all of these are screens, all of these are screens, each of these are a screen, this is a screen. All of these pixel bands that go all around the stage were also expected to be part of the previous. I talked them out of that, luckily. But all of these to just be like a single color, but they're also mapped. So there was just so many things that could be done in this, where we had to sort of cut it short at some point. Previous is always like, what is it for? What's the main purpose of this? The main purpose is to approve on timings, to get everyone on the same, like on all these different teams speaking the exact same language, and also approving the video assets. And seeing that, especially in this case, seeing that this stage and this stage have content and that things travel between them in an interesting way and such. So this is just a tiny little pic of what we did. Yeah. Oh, thanks. It was very crash and burn. Go fast. Yeah. As it is. So I can show that in this one. So yes, I do one. Well, sometimes I do an animation comp for each. In this one, we're not doing any animation comps. But yes, the way that I teach is like make an animation comp and make it control all of these parameters. So like this kind of stuff, and then everything is just inheriting. So if we dive into the queuing system for this one real quick. Song settings per song. We basically have these like all of them named and like some standard start settings that they have, and then per song we set up both a initial look that we set up with the band, which is literally us moving sliders and recording like, this is nice. And then we type them all in. I don't do that anymore, but this is what we did in this one. Now I just figured out that on the constant chop, there's this wonderful button called snap that will snap everything. And if you put them in, they'll just be saved. And this is how I make my presets when I do quick presets now. But then we pass them also on into like an interactive. I don't know what we have that's interactive here. So we receive the vocals, 2 levels, 2 singers. We get how far they are in the song, because I'm always running the song track as a demo backup fallback for visual audio reactivity, especially. Audio reactivity, this is switched to the live interactivity. OSC in from the band. In this case, we're only using black out, transition in and transition out. And then we have our min and max values that we've set in these settings. And in this case, for this song, we're just allowing the band to trigger between those 2 looks, actually. So it's just 2 looks for this song, and we're just going back and forth. So no like animation comp, but I have definitely done entire arched of songs and like music videos just off of the animation comp. Yeah. Like actually the music video that we did for this band was done from the animation comp. Cool.
Thank you. Oh, thank you. Next, we've got Greg from Derivative. But yeah, like we've been kind of doing, short break before this next one. And you're not going to want to miss it.
Good.
Okay.
All right. Could you all give a huge round of applause for Greg?
Hi, everybody. Welcome. There's been really amazing talks today in the workshops. Really inspiring. This is going to be more like a parts list for your future work talk. But I just wanted to talk about the new operator family in Touch Designer that we announced about almost a year ago, and it's been in alpha since then, and we just posted alpha number 6 yesterday, and it'll be the last alpha series until we go experimental, which means that POPs would be available to everybody. So that would be the time at which we merge POPs with our new file format plus new cloning, and that's going to be the target. But we took this along to do a alpha program because it was building a new operator family is a huge undertaking, which needs a lot of design and undesign and redesign and undesign. So we didn't want to. We wanted to be able to backtrack a lot, and we did a lot during this past 8 or 9 months. Actually, a lot in the last. We're almost at 3 years for the project, but we're kind of happy where it's at. So POPs stands for point operators, but it kind of means points, polygons, point clouds, particles, anything that starts with P. But it's kind of more than that. It's kind of the best of, and it runs all on the GPU, which is great. And it's kind of the best of what SOPs are, plus modernized, very modernized, and also plus the best of what CHOPs are. It's math, data manipulation aspects of it, and TOPs as well, because TOPs are grids, arrays of pixels, and within POPs you're thinking also grids, arrays of points. So it's kind of the best of everything, and we originally thought of it as being for 3D graphics, but it's kind of almost like a data manipulation language and system. So pretty happy with it. And so kind of here's where, if you haven't, first of all, I wanted to ask you, how many people here are on the alpha program or have used it, the alphas? So it's about 20% or so, not a lot. Okay. And how many people don't use Touch Design at all? What percentage? Okay, so it's about 10%. Cool. Yeah. Okay, so so we're now up to 90 operators and counting, and you'd see a lot of them kind of familiar with SOPLAN, and some of them actually are math oriented, like the math ones, and some things are image oriented and stuff. So anyways, it's all, and we so the other background is we thank you for tolerating doing particle systems in an image operator family, TOPS, for 5 years, plus years. It's kind of weird to put particles in images, but we kind of had to. It was kind of an easy thing to do 5 years ago or whenever they came out, probably more. It's an easy thing to do. We only had to add a couple of operators for TOPS. I had to add the point file in and a couple of transform things and stuff like that. So that gave us enough time to actually do POPs right. So we couldn't have done it all in one shot. So it was really good to be able to go for that number of years where particles were in images, but now this is kind of their right place. That's starting with the point file in POP, so that going into the POPs line. So okay, now we're in, okay. So yes, and just so you know, there's lots of things to introduce here, but you get points, primitives, and vertices, very similar to SOPs. And the on the GPU, you're kind of limited because you can't. Well, you can only have points, 2-point lines, line strips, which are arbitrary numbers of lines that segments that can be closed, triangles and quads. You can't have hexagons or octagons or whatever. You just have to do it with triangles or quads. So that's kind of the limitation of GPU. So slightly different, but it doesn't get in the way too much. So rather than going through a bunch of these things one by one, I want to show you. Oh, first of all, yes, these are a bunch of studies done by Simon Alexander Adams, Polyhop, which I snagged from his Instagram, and I believe all of them except for one is POPs. I think this one's a top thing. Is Simon here? Okay. The other ones are? Okay, good guess. Okay, cool. But, and it's kind of interesting what Simon does. To me, this is kind of like what a music synthesizer would be, the kind of patching of things, the way you feed things into other things and get other branches, and clamping and limiting, lots of that here. Spline curves shooting out for things and coming back in and so on. But to me, it's very synthesizer-y, and I kind of find it very interesting, all these studies that you've done with it. So, another one of our users, Darian Brito, put out this thing called, actually it would be just, so he was on the Alpha program, and he was kind of, this is Darian's self-teaching project to try and remember or learn how to use POP. So he went through a bunch of them, and he's made an example for each one of them. Well, not most of them here, and network inside, description, and I found that he posted this a couple of months ago, and he'll be completing them in a while. But just the way he's kind of like explains these things for himself, but also for other users, is kind of remarkable. And here's like the several primitives, triangles, quads, point clouds, and stuff like that. Let's just jump through a bunch of them as examples of what he's produced so far. And this is in the forum that's for Alpha POPs and that everybody has access to now. It's kind of this common thing in which is kind of quite easy now in POPs, where you can define a field around a bunch of points and with a kind of roll off and a weighting factor as a result, and then use that number to push points around and stuff like that. Field, this also is fields used to push things as well. A bunch of GLSL things, and grids in broken. Anyways, just bounce through a bunch of them. Lines they're splines, but they're really subdivided edges with so we're treating splines a little more seriously, and using lookup into textures to generate data, i.e. sphere radii. There's Vincent Huzet, who's one of the main programmers of POPs, has spent a lot of time working on a mechanism to expose neighbors of points, and the closest neighbors to the point come in as attributes that you can get at and do stuff with. So one of the things is it's a common thing of doing proximity edges and stuff. So anyways, I'll just bounce through a couple more of these. Sprinkling and generating sprinkling points and stuff on surfaces. et cetera, et cetera. So anyway, this is kind of like interesting set of examples that he's made. And my favorite one, trail. Yeah, and we spent a lot of time on this thinking about trail. So, you know, the idea of trail in chops is obviously, you use it a lot, but in pops we just made it a little bit more complete, connecting the dots in different directions, subsampling it, filling in the gaps when you skip a frame, stuff like that. So it's pretty full featured. Oh yes, as examples, they're all interactive. Okay. So yeah, what I wanted to do is I'll give you another example as well before I get into the new stuff. I was going to talk about only the new things that came out in the last Alpha 6, but I think because of people's lack of background, I'm going to cover a little more general stuff. Here's another example of, oh yeah, this is, first let's do this one, humanoid. Okay, so this is kind of a cute one made by Vincent, but it's, well, the giveaway is, I shouldn't tell you what it is, I don't know if you can tell what this is, but it looks like two guys fighting, as they kind of are, and it's an FBX model that comes in as, you know, usual FBX thing with its bones and rigging already in it, plus a bunch of animation channels, and done some secret sauce somewhere here and there, pulling channels together, and then, so then it gets into the pop land, making a circle, is just usual instancing stuff in touch. Kind of the interesting thing about the copy, well, here's, yeah, instancing here, but you don't have to instance, you know how you instance in geometry to render stuff, so GPU is so fast you can actually instance a whole bunch of things using a similar mechanism with a copy pop and just keep the geometry that it generates in memory and then do post operations on that. So it's kind of like nice to be able to actually just catch it before it renders and then you build stuff. So here's this circle instancing a bunch of things that would be, hang on, here we go. Yeah, there's the guy's time offset with the animation channels driving it. This one uses a very small shader to do this thing a little bit efficiently, to grab animation channels and apply it to the different parts. And it's kind of an interesting thing too, because this thing says it has a dimension of 1605 by 10. So we have this idea in Touch Designer now, in POPs now, where the data can be arranged as grids. And it's in SOPs it was kind of simple because you had rows and columns in a mesh or something. As soon as you went to do things with convert to line strips, or as soon as you copy it and many times, you kind of lose the row column information. But in POPs it goes much farther. Each model is 1605 points. But there's 10 of them, so we have a dimension of 1605 by 10. So that information is passed on from operator to operator, and we end up in situations where if you instance a rows and columns mesh 17 times on a grid, another grid, you end up with a 4-dimensional data structure, and you can get at that information on the GPU and with your attributes. Okay, so anyway, so that these guys get, then we get skinned in a different way with a primitive reskinning, and then that gets kind of level of detail and null, and let me see, it gets obviously, yeah, gets divided and then rendered. So, okay, so that's just an example with kind of a pipeline with some subdivisions and reconnecting and stuff like that. Okay. So I'm always trying to test pops out on different cases. So I'm kind of the test department, or part of the test department, a derivative of some of the new stuff coming out. This one component's been around for a while on the palette. It's one called gesture capture, and it used to use SOPs and chops, and it was kind of a mishmash of things. But I wanted to see, how well would it hold up with doing it with pops. So the original one did captured your gesture into a keyframe thing, and then for every line it generated a component. So this is the capturing part, just from chop coming in, on off to trigger it, say basically capture it, and then at the end of a line it'll close it, kind of thing. And so it captures a whole bunch of lines into this one component called lines. And for every line stroke, you get a component. So this might scale up to 100 or a couple hundred, but won't scale up to Rembrandt or anything like that, which is probably thousands or millions of strokes. But anyhow, the data comes in. It's actually held in a keyframe component, which has been around forever. And then it goes into Chopland, and then we start adding smoothing with a line smooth, so it goes from more jerky things. Look at the samples, they're all over the place. That's the original data, so this is kind of resampled to be more evenly spaced, so that's kind of what line smooth and line divide do. And then is various different attempts of the method. And then, yeah, I guess more resampling. And then this one operator was really amazing, called line metrics. So it used to be, if you had a bunch of points together and you wanted to know how far away is the next one, or what direction is the next one, and what direction is the previous one, sometimes you have points that are all in the same place. You want to be able to deal with that. So this thing called line metrics does that. So it adds these attributes called direction, displacement normalized, distance, blah, blah, blah. And that comes out as, I'll just show you pop 2, as attributes. Okay, so hang on. Let's just transpose this so you can see the attribute name. So this is kind of a typical thing in a pop. You have position, 0, 1, 2, color, 4 components all the time, direction, 3 vector, displacement. This is a scalar, distance and time and so on. So the attributes in pops are different data types. They're usually floats or float 3s and stuff like that, but you can create integers and double precision and matrices and vectors and so on. So it's pretty whatever the GPU can deal with usually. Combining attributes, and then this one node called MathMix is it's kind of like the math chop, except it does a lot more. And we thought at first we thought, oh, let's just make the pop one very similar to the chop one, and realized the chop one was first made in 1998, and we've come a long way in terms of our thinking of what stuff should do. So this is almost like a partial shader builder. We're using sequential blocks where you basically every block does some math operation, like out of this selection of singular operations and combination of A plus B, and then some ray tracing things and length computations and looping things and so on. So like everything that we could think of is in this menu in terms of doing straight math on 2 or 3 numbers at a time. And it goes a little bit daunting when you look at it this way, but if you middle mouse click here, you can see at the bottom here what it's doing. It says velocity is equal to displacement divided by time step, and speed equals the length of that. So there's a kind of a way of actually comprehending a little bit better when you look at other people's work. Rearrange, yeah, there's a whole rearrange pop on itself. And then curve, yeah, this one's like similar to the S curve chop, except you can do more stuff with it, like make it symmetric, whoops, yeah, in one shot, and normalize it, and then you can add more segments to it. So this is a segment plus, and then add more. Hang on. Yeah. Oh, okay. Hang on. Just sorry. Yeah. Anyways, it's a multi-segment S-curve chop, and that way you can generate kind of like functions y equals f of x in this way and use them as lookup curves, for instance, for other stuff. So anyways, we went a little bit further with this. It's it is just a bunch of points and with z equals 0 with extra attribute called curvature. So yeah, we can also tag curvature onto curves as well. So when you need that, you got it, kind of thing. So yeah, and then it just gets merged out as line strips or whatever it is. And here's a chop form of it, etc. So, and then all these things get merged into one thing using a merge pop, pulling in by pattern everything it can find into one pop with all the line strips combined, all 5 line strips now. Yeah, I'm at 20 minutes. I'm about 10% through my talk. Okay. Okay, I knew this was going to happen. So anyway, that's kind of the idea. Again, this other thing is a way of tracing your way along the line. Okay, so forget that. Don't. Okay, this is new stuff from Alpha 6. Well, for those who care, the engine component can send pop in and pop out. That was a major feat that took a while. Actually, we'll jump over this one for a second. This Gaussian slat stuff. So this is somebody actually put out an example for it using the official of Touch Designer, and this is the example that runs in any web browser, but it's the Gaussian splat format has a way of representing all the splat parts as well, a bunch of attributes that define it in a PLY file. And so the secret sauce here is, well, there's this, where's the point file in, which does some crazy stuff to bring it in. Oh, it's all up here, yeah. Yeah, so here's the point file in, which pulls in, it creates using sequential blocks. This is all your file coming in, and you have pattern matching to pull out channels from, or what they call elements or whatever from the file, and generate pop attributes from it. So this is kind of like a pattern matching thing that somehow manages to get a position, a color, a float for rotation, plus this nutty thing, which is 15 float threes, which is fine what the splat kind of coefficients are. And so that is one node, which goes into a few things here. It not doing much, but then they're combined together into, and there it is. It's just dots, but then it still has all those attributes on it. And lo and behold, the shader, which is it's been worked on all over the place by a bunch of people, but the compute shader doesn't really do that much. And so that's one, and there's another. I think it's the only shader we need. But anyway, so this is kind of like a test case to see like how well is POPs able to adapt to this kind of thing, this Gaussian splat stuff. So there's more to go, but that's kind of where we're at on that end. Okay, but let's okay, forget about that. Let's go on to the other thing. Don't forget about it. Just uncook it. Yeah, ZMX. So about a year ago, maybe, yeah, probably a bit less, we started to ask the question, how good would POPs be able to represent DMX data? And, we have points, we have primitives and line strips, attributes on primitives and attributes on points and stuff, and we thought, can we actually channel data? And the good thing about POPs with DMX is you already have position. Every dot on a LED thing can be a position in XYZ space. So you're starting off with that, and then you add in information like, in this case, just color, but you can add in a lot more information that goes along with a fixture. So we came up with this. Yeah, so this basic thing is just position with color, which is being done through a lookup of a texture. Yeah, and the lookup, this is nicely designed to pull in from 3D textures and into a pop point. And so we came up with this two pops, which is a DMX fixture one and a DMX out one, which similar to the chop version of it. But the fixture one, we didn't have a fixture one in chops, but this is where you add the extra information. So for every DMX channel or set of channels, you have a block of sequential parameters. Here you're just naming it color and getting it, well, this is one thing, just taking this attribute. It's coming in as a 8-bit versus 16-bit or 24 to 32-bit number. You're going to pull it in from the points, and you can actually pull it in from just a constant value. So you can just constant value here, send that color out to the fixture for testing, for instance, and so on. So that's, and the nice thing too, there's also the third operator for this was DMX map, and that's, I gotta make it active. Yeah, so it shows you so you're at one of the pages for DMX is the network, subnet, as you know, universe channel stuff, channel gaps, quantizing universes and stuff like that. So for one fixture, this is sort of what the map comes out with. So this is kind of the data values and stuff. So, okay, I'm glad you think it's interesting. Okay, phew. Okay, so and then so then you kind of composing these things for different fixtures. So some fixture which has 4 of something with blobs of pixels on them or dots, and that itself comes out as so the DMX fixture things adds a whole bunch of attributes to it. So this one has a ton of extra things. So here's how many blocks, about 19 blocks. So it defines 19 aspects of a fixture, from pan, tilt, speed, so this moving head, dimmer, strobe, and so on. So each of these you can define as a data element that gets turned into the stuff that shoves out to the next section. And again, let me see if we got, let's just turn this on. Then the channel name that you given it comes out here. That's right. And all its information, there's, all this net, subnet stuff. So fine, so you got a bunch of them in a setup. And then, see, this one also has, and then, okay, let's just, to the punchline, DMX out gathers them all together, and it manages conflicts as well. So you don't want to, as speakers before were saying, you have all sorts of issues of addressing, stepping on each other. So hang on, this would be active on. Oh yeah, I got to turn this on too. Yeah, and then you choose your interface, ArtNet, or the common ones that we've been supporting up to now. And then you can just kind of go here and scroll through all your stuff. So Totally touch designer style. No super fancy interface for this yet, because it's you just kind of, it's a super big table, and that's what it is. And yeah, you can see where the you know, the channel gaps are. I wish this thing didn't. I wish there was a feature to keep the first line, first row. Note to self. Well, yeah, that's what happens. Things piss me off and piss off people inside the company, and that's how software evolves. First line, but but it's yeah, it's good. So you know, there's example of the stuff being pushed out, and well, you get the idea. So that's the map on the DMX out. There's also subtleties. Some of the DMX channels are bitmaps, and there's ways of filling them with data. Some of the channels are 16-bit in different orders. Sometimes there's gaps between things. There's a ton of crazy cases. We're trying to deal with all of them, so we're getting lots of input from some of our alpha testers on what they should look like. Like, what's this one here? Marcus said, look at this one. Oh, so what's this? A couple of lines of something. I don't. Okay, I guess why? Okay, so anyways, there's a meaning to the fact that a bunch of points are actually joined together. They act as one kind of unit that gets their own attributes, that gets their own. Right. So the line strip itself, you can choose to get your attributes from not just from the primitives or from the points. That's why. So it turns out that touch designers, well, Pops is really suits DMX data pretty well. So we're kind of lucky, because we hadn't anticipated this when we first set out to making Pops. Let me see, what are the most notable things that I should talk about that I've forgotten? Oh yeah, for those who, this is kind of interesting. So we've generalized something whereby every point can have its own parameter values. So what does that mean? So generally, with a transform on a sphere, if you rotate, all the points rotate together, right? So that's the way it's been for everything. But if you choose to map to the rotate Z channel an attribute called rand angle, every point will get a different rotation based on the values of random angle. So this is a way of driving points, and also same thing applies to the noise pop. Every point can have a different amplitude or offset or whatever. So there's it applies to a whole bunch of operators. So this is architecture that we decided to put in, and this is why it is where it is right now. We designed this in two ways. We abandoned one. We went with this one, and this is kind of you'll see this not only here, but also in the noise. Okay, so here's another example where what goes into the final shapes here is these are just flat. This is just flat right at this point, but it has lots of attributes on it. And it also, as I noted before, if you middle mouse click, this thing has a dimension of 50 by 50 by 3 by 3. So that's the organization of the points. If you pull it out in a chop, you'll see the way I've put data into here. This will be normal. This will be the normalize. Yeah. Anyways, these are just attributes that are going into the noise, and the noise then is driven by a bunch of attributes coming in. The amplitude and the gain is being driven by normalized 0 and 1. So it's basically 0 this way and 1 that way. And in this case down here, it's kind of a similar thing where all the each part of this has their own values for the noise parameters. So each grid gets a different set of parameters. And again, the thing going into it is the same thing as the 50 by 50 by 50 by 3 by 3. So really powerful architecture for that. Okay, so let me just pop out. Hang on. Wait. Oh yeah, this is another interesting thing too. Yeah, so cut to a chase. A field pop has parameters to generate 0 to 1 weighting values. I should show you a basic example of that. I will in a second, but this idea now is that some operators, like the field's forces, they're usually driven by like one set of parameters, many parameters that can define it. But if you send it in, this is sort of how we do instancing with text in the geotext. You give it a spec pop, which has, in this case, it has 3 points, and each point represents a field. So if you have 10 points, you'll end up with 10 fields that you can drive externally. And we do a similar kind of mapping where we take attribute names, radius x, translate x, and translate y. That maps to and overrides a radius and translate x and translate y. And that means that you can custom each field nice and cleanly, which leads me back to the beginning of everything, the point pop. This is kind of like the add SOP, except simplified. There is the add SOP became the point pop and the primitive pop. So anyways, this just generates points, and it's kind of a nice thing. Again, it illustrates one other, and I'm about to finish. A nice architectural thing about pops is that you can define, like, okay, so we've had that that shitting on the constant, which does that and that and that. Okay, so now you can't control anything here. Well, okay, so this goes the opposite direction. And this isn't using custom parameters. It's watch this. So this thing has three parameters that we've defined. And where did we define them? We define them on the setup page. So here you can say, okay, I don't want any P position. I just want attributes of these three things. And this is what it ends up with. I want to do this. I want to have 3 columns. So fine, I create a new attribute called radx, another one which is a float, another one called tx and ty. They're both floats. And so by doing this, we get them as attributes created here via parameters. So you go +1 and add, call it blah, 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 and make that a float 3. Then we go to points, then we got a float 3 here, and that becomes a parameter in your sequential blocks. So it's kind of works like custom parameters, but it's very pop focused. So point works that way. All it does is output points and point primitives optionally, and the other one, the particle pop. Not particle. I didn't even talk about particles. But anyways, they're there. Yeah. So I don't need to belabor that one. Which things did I miss today? Okay. Yeah, particles. Yeah, okay. So there you go. Okay, and hang on. And I think I should stop soon, right? Do I have 0 minutes left?
I think we got time. We got time. Everyone's here for it.
Okay. Don't say that because I'm going to go forever.
I mean, we could stop. We're doing a Q&A
Yeah.
that involves you, so maybe we
Okay.
could just move into that too.
Yeah, we can. Okay, just so you get. Okay, so I'll just give you a wide view of it. Generators, yeah, including curves plus point cloud generators and fillers and grids, which are no longer 2D grids, but they're also 3D grids. So you can now think of grids as 3D things and randomize, so you can kind of soften things out. So that's kind of, and then we talked about math briefly. Neighbor stuff. Okay, so this is important. So wait a second, basic particles. Yeah, so here's the same kind of things happening with a force pop, which there's 2 of them done in the same way I just showed you with fields. But the neighbor stuff was something that Vincent Jose spent a lot of time on, and a bunch of points, and you want to find what's close to it. So the way we do it in this method is you create attributes that represent the index of the closest point. So NEBR is neighbor, and these are the 4 closest neighbors to point 0, 4 closest neighbors to point 12, and so on. So, and the reason why you don't see all the points is because we have thinning data out every 4th or whatever. So you can condense the amount of data that you're looking at either randomly or using steps, or using random thinning out and stuff. So this helps manage millions of particles that you are trying to analyze. But anyways, this is the closest neighbor, and then you can use that information to do stuff with it. Here's an example where you're comparing two together, one pop with 5 points in it, and one pop with 1,000 or something. And these are just drawing lines to its neighbors using some, whatever the trick is here. Yeah, anyway, something like that. I'll just, averages and smoothing. So you can use neighbors to actually smooth data out to soften an attribute. In this case, color, which starts off being kind of harsh, random colors, and this is more averaged out, blurred out colors. Okay, and last thing here. Yeah, and this, this somehow, it uses kind of like a ray casting to determine whether you're kind of inside or outside a volume for each point. So it's, you often want to do that in modeling, not on the rendering side. So ray is, we just kind of added features so we can test properties of data relative to other shapes. In this case, just a polygonal thing that surrounds it, outputting the ray distance and number of hits and blah, 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 blah. So, and then thinning it out and deleting things you don't need, and sizing it based on proximity to the edge of something and stuff like that. So, let me see, what else okay, let me check my notes. What did I not talk about? Smoothing lines. Okay, that's it. So thanks very much. I appreciate letting you. All right. So it's more food for your next projects. Parts list.
Awesome. So we're going to just keep Greg up here, and we're going to do a little Q&A. Also, maybe if Isabel wants to
too.
come up.
And then also, just to like invite, maybe like feel free to just kind of stand up here. But if you performed or did any workshops, also you can be available for questions. I'm guessing most will be towards these two. But yeah, let's just get started. Questions, go.
When? Oh, did I hear a when question?
A question of when, yes.
You know, well, Alpha 6 is out.
Alpha 6 was out yesterday.
You just have to, yeah, what you have to do is you need a valid current educational or commercial license to Alpha it, and you just have to email support@derivative.ca, and you'll get in there pretty fast. And then we're going to go into experimental in a couple of months, and that's when everybody gets their hands on it. So, and when it goes official, I'm not sure, maybe a few months after that. Experimental to official is usually between 2 to 3 months, I think.
So,
hard questions for Isabel, please.
No, I have one, Greg. This is Brandon. So for the DMX fixture stuff you're working on, right now we just kind of have to do it raw with the tables.
Yeah.
But in the future, anything where I have a whole bunch of fixtures and I just want just the tilt of every fixture, or like pattern matching of like wanting to grab at those vertex attributes, but even if they're in different places and different channels.
Oh yeah, actually yeah, you might have seen a to-do in there. One of the to-dos is like you want to go dimmer on everything down to nothing. So you can do that with, well, they're just parameters, so you just do everything upstream to whatever is being fed into the DMX fixture pops. But there is talk of having kind of global affecting one of the channels uniformly, like just dimming everything on top of what it currently may be set to. Does that kind of answer your question?
Yeah, right now it's replacing the table itself.
Yeah. Yeah, something higher. I didn't say too that. God, I forget who the name of the speaker 3 speakers ago was, but he mentioned that GDTF file format that is kind of industry standard, and that's we're starting to look at that too and play around with it. But it's a XML format that describes 2 things. One is the logic and electronics, or whatever the DMX signals are expected to be set to. That's one. But also it includes a geometry file in some format, polygon format, which represents what it looks like. And so that GDTF is kind of supported by a lot of products in the industry, Unreal and a bunch of others. So we're starting to look at GDTF files. So what it would do, though, is we need to make a converter that takes the GDTF file for each fixture and generates a touch designer network from it. And there's a lot of it's not perfect. It's a lot of there's a lot of what do you call it, black magic in it. Not the company, but just black space magic. Anyway, but yeah, that's another next step for us. But I think people will just be making their own, for the most part, their own fixtures.
Got another question here?
Yeah, I just wanted to hear a little bit more, if you don't mind. I'm interested on those 2 kind of design philosophies that you pursued when you guys were developing POPs. And I was interested in the approach that you've taken. What exactly is happening? Are these all separate shaders and everything just remains in a buffer in the GPU? Is that why it's like, why did you choose the strategy you took? And what just want to know a little bit more what's happening under the hood.
Yeah, okay. I won't go to that network. Okay, so the answer is so it's all compute shaders underneath everything. There's maybe 2% or whatever that aren't. I'm not maybe not even that. But anyways, it's all compute shaders, and we also have the compute shaders called GLSL Advanced, GLSL, and GLSL Copy. These ones, GLSL Create, GLSL Select, and there's one called Topology, which lets you program GLSL, but it's kind of the inner guts exposed of how to make stuff. Compute shaders are pretty finicky and complex, but we've tried to make it easy to coded stuff for GLSL. There's there's hang on. I don't know if I can. Oh, I'm not on the internet. But there's anyway. There's lots of documentation about how to build it that we've been developing, we've been writing. So, does that answer your question? And the data stays on the GPU as much as possible, and we try to avoid not sending things to the CPU and back to the GPU. So there's lots of tricks, which is why some of the things are done exclusively on the GPU. So, for instance, there's something called the Analyze, which stays on the GPU, analyzes all the data. You can take all the everything, and this is all the attributes that it's generating, and send the analyzed data to hang on, transpose. Yeah, so this all is sitting on the GPU, but then the nice thing from here is you can use these numbers downstream without having to go to the CPU to bring it from pop to chop and then do stuff in chops and then back on the GPU. It stays there. So we're doing our best to keep things on the GPU so it doesn't stall. It doesn't matter as much on Mac OS because it's all shared memory, but on Windows or on dedicated graphics cards, it is an issue. That kind of answer your question?
Any more questions? We got more questions.
Could you go back to the operator that had the guys who were kind of doing the fighting animation for a second? Just
okay.
I don't know quite how to properly word my question.
Okay.
So, yes, that one where the guys are kind of like more visible. Yeah. So let's say that you wanted to have, an operator or a scene like this where there's like two guys looping animations. One of them's on a 2-second long animation. One's on a 3-second long animation.
Mm-hmm.
And it seemed like you were sort of like feeding it a table with all like the points.
Yep.
So
That's all the channel is for n-second animation. So they're on exactly the same length of time. Yeah. So you're just doing an index lookup into this chop.
So you'd have to normalize that to like a 6-second long animation then, right? Or could you feed it?
No, you could send a different table in for every person.
Okay, cool.
Yeah, because this would be the small GLSL shader that does that here I mean you can code it so that you're actually pulling in more than one set of attributes or more than one input. The operator this operator can have like 20 inputs if you want, and each character can use a different input. That would be a way of doing it.
Cool, thank you.
Okay, thanks. Good question.
Here. I got you right on your left.
And since this is kind of a different mental model of working with data, and especially for people who don't use SOPs too often, is there going to be since we were like crutching along with, and that's overspeaking, with TOPS for so long for particles and such, will there be kind of learning resources regarding, if you did it this way before, here's new way, here's the more efficient way, here's the way we've built for you?
Yeah, and well, in our one documentation page is the SOPs versus POPs way of translating things, just generally how they're different from each other. It's not really geared towards. I don't know. I think the it's pretty easy transition from going from particles in tops into this. You just got to look at some of the examples, like the ones from the Gerritsen brothers. Hang on. Yeah, so I think yeah, I guess more the answer is it's not that hard going from working with particles in tops to pops here. This is the example from the Gerritsen. So yeah, in fact, this examples folder is examples from different users on things that they were good at. So here's the Gerritsen's ones, and there's 6 examples. Yeah. So and the network would be like here, and they're usually a point file in, model coming in, and then just some math magic on stuff. So it's just lookups and deformations. It's pretty straightforward. Okay, so and the other thing too is, like, for instance, there's in Topland there's a transform or whatever. So in POPs there's a transform. So it's pretty one-to-one in many cases.
Okay, thank you.
Mm-hmm.
Hey, I've seen a lot of new parameter looks in POPs. Like some parameters had like a toggle, and next to it was a field, as well as some stuff that was hiding other parameters. So is this coming to custom parameters, or is this gonna be like POPs only?
Yeah, actually, hang on for a second. Line metrics. Yeah, you're talking about stuff like this, where it's a toggle and then it enables a string kind of thing.
Yeah, this kind of stuff.
We've been doing also, not here, but in parallel builds, a revamp of the way custom parameters are constructed to make them closer to what is possible with non-custom parameters. So Rob Barrows and Ivan Del Sol have been working on that a lot, and the whole team actually. So that's kind of like the new version of, and it's not here, but it's what I'm talking about is, I need your toolbar, dude.
Yeah, you do.
Fuck. What a loser. What a loser. Jeez. Okay, you have to go this way. 10, whoops. 10 clicks. Yeah, this is getting a bit of a overhaul. In many ways it'll look the same, but some of the stuff here will change. So I've been working on that part of the project, so I don't know more about it.
That's great. Thank you.
Yeah, but I realize at one point we said, oh, but everybody's going to be asking for this in custom parameters.
I saw there was a nice collapsible parameters on the noise pop. Double.
Oh yeah, wait a second. It's a noise. Yeah, that's. Oh, Jesus, there's so much stuff. So let's example. Just math here. Okay, so math in shops, you get one set of numbers, parameters for that apply to all your channels. And here, because the way attributes work, sometimes you want to have parameter for parameter values for separately for X, Y, and Z. Or even if this was color, you wanted 4 values for a parameter. So this architecture of extra parameters columns is new. So there's there's a whole bunch of new things that we did for Pops that are, some of it's going to percolate back to other families, but not right away. We're just trying to get this right, and then we'll start porting things back to other families. But does that kind of answer your question?
Yeah.
Yeah, but you were talking about something collapsible in P in noise. I don't know. I'm not sure. I don't know.
I think it's actually in the bottom of the math chop.
Or
math pop.
Yeah.
The
That's
double.
Right. Yeah, this thing. Oh, this thing
Yeah,
here. Yeah, that just opens up more parameters that are related to.
That's
to
fancy.
Yeah.
We got a question from online.
Yeah, from the live stream, Velo's wondering if after the Pops is released, if you all are thinking about potentially doing a 300 level series for tutorials.
Yeah, do you want? Oh, Isabel, you can answer that one. We're still working on the 200s.
Yeah, we're still working on the 200s, and as Greg would say, there's a long way to go. But definitely there will be 3 or 4, it might even be 400 by that time, but there will be more learning resources put out by ourselves. And
there's a lot to do in 200s.
there's a lot to do in 200s.
And there's, yeah.
And we you know, I mean, there are topics that we would definitely need help on from community, and if you kind of know what the format is, and there's something you think you could fulfill, let us know.
Other questions?
Thank you.
But I might have been imagining things.
Does the new DMX out op, does that handle the like overflow intelligently? If it's like overflowing RGB into the 512, like the universe overflow.
There's some toggles in there to separate things out if they're going to cross
Split.
a boundary of
Nice.
a universe or something.
Right. Yeah.
And it'll error if there is some overlap.
Cool.
But may not catch everything. But
okay. Awesome.
That's
Thank you.
kind of the idea. Yeah.
One quick thing I just want to throw out here is I've talked to a lot of people today doing really cool work and amazing projects, and I'm always looking for interesting things to write about for our showcase. So if you feel like it, reach out and we'll talk about it.
Oh, and I just while I'm thinking of it, we're going to see Game of 1,000 Boxes by Dave and Gabe tomorrow at 3:30. And anyways, I recommend people go check it out. Looks like we got a preview at his place, and actually he
Really fun game.
Yeah, he talked about Gabe talked about it at the Volvox thing last summer, I think it was. So.
There's a video on our YouTube channel from the
from
Touch
that,
in
but
NYC last summer.
It's a really well-designed game show. And yeah, we're always want to know what's happening in New York City. When let us know any stuff that you're involved in while we're here for the next day. We're willing to go out after midnight. Is that part of it? Yeah. Okay.
Well, we're going all night.
We're going all night. Oh yeah. Yes, that's right. Well, we're going to go see Goldie tomorrow
Well,
night. So.
no, we're not.
Okay. Any other questions of Isabel or I? Anything that you want to bring up, Isabel, about what's up?
We're not doing our Berlin event this year. Instead, we're going to do 3 shorter events, full day nights in London, June 15th, Dublin, June 28th, and Paris, July 9th. So if you're in any of those places, we just got our location sorted out and the dates confirmed. So the next few weeks are just going to be curating and programming and promoting and just and then going.
Well, yeah. Thank you all so much.
Thank you.
Thank you, guys.
All right, so this kind of goes from talks to performances, party, whatever. But I guess two quick asks, hopefully quick. We're going to do a little team effort to move all the tables or chairs and put them against this wall. And then I'd love to take a big group photo with everyone that's here. And then we're going to get into a bunch of awesome AV performances. But yeah, let's move those chairs. Blast the music.
What did I do? Yeah, Molly. I was exaggerating.
Thanks, yes, same here. Thanks for coming. Your wedding was so much fun. It was a great display. It's good to go to the brunch the next day, too. That's how it kind of rolled it. Yeah, Raj was playing the first act or something like that. Yeah, so let's see. Yeah. Are you going there?
Yeah, I think so.
Whether you are or not.
Yeah, but we're seeing you. She's waiting on me in the car.
Yeah, we got Brian in the house. All right. All right. I don't know. I can't control people with my Uh, 2-minute warning or 5-minute warning, probably more realistically on the group photo. But if everyone wants to come a little bit closer to this nice warm light. So warm, so nice. Oh yeah, you can come with that. Yeah. No, yeah, you do it. Go to the warm light. Hello. And like actually grouped around. All right, yeah, let me turn this up so I can be heard. All right, so actually even go a little bit further into the light. They only have the stage ability to light here at Chemistry Creative. Who does not want to be in the photo? And who wants to stand on this? Oh my goodness. All right, 1 minute left till the group photo. Get in there, Torrin. All right, we're gonna see if Jeff is able to balance on this. You don't. Do you want to? You don't care about sound? All right. So we've got a couple cameras. One's going to be this iPhone. One's going to be this real camera, and then we've got a 360 camera somewhere in the crowd as well. Let's do a little 1, 2, 3. I'm going to join it. But here. All right. Maybe people, if you think you're in the first 4 rows, just go a little. Just be a little short. Very nice. Oh yeah. We got Jeff on the camera and Dan on the support. 2, 1. Everybody say movie file in. I don't know what that is. All right, that was good. That was good. All right, thank you guys. We're gonna start AV sets in a couple minutes. You can leave the station. Now. Now I'm going to invite you all to not be hanging out in the stage.
Yeah, exactly. And so how much time did they give on that? They really spent, I mean, Zero Chill, like, already in there for the whole week.
Hello.
Festivals, like,
Lyle.
some parties it's like 6 hours. It really just depends on the party.
Lyle.
Hello, we're gonna get started with Reckoner and Casalina. Casaquila. Yeah. All right, freaking blast it. Oh, Misha.
Hello.
The trained models that you could download and run locally too would mean that for installation.
They kind of get into like almost medley. Like, what are we here for?
Okay. Ready?
for your perfect camouflage. Don't turn around. Don't make a sound. Fight for your perfect camouflage.
This is a Manhattan-bound Q local train. The next stop is Avenue M.
Stand clear of the closing doors, please.
This is Avenue M. This is a Manhattan-bound Q local train. The next stop is Avenue J.
Stand clear of the closing doors, please.
This is Avenue J. This is a Manhattan-bound Q local train. The next stop is Avenue H.
Stand clear of the closing doors, please.
This is Kings Highway. This is a Manhattan-bound Q local train. The next stop is Avenue M.
Stand clear of the closing doors, please.
This is Avenue M. This is a Manhattan-bound Q local train. The next stop is Avenue J.
Stand clear of the closing doors, please.
This is Avenue J. This is a Manhattan-bound Q local train. The next stop is Avenue H.
Stand clear of the closing doors, please.
This is Kings Highway. This is a Manhattan-bound Q local train. The next stop is Avenue M.
Stand clear of the closing doors, please.
Joking out. Too afraid to feel tears on my face. And joking out. Too afraid. choking out. Too afraid to feel tears on my face. Choking out. From your fairy tales and happiness, choking out. Too afraid to
Thank you. Thank you. This is Kastakila, and I'm Reckoner. Yeah, I can talk about how I made the music. So I have everything you heard today was being controlled using code. So I have a.
Oh yes.
I have
Thank you, Saman.
a
And
bunch
Katskilla.
of a big wall of Haskell text, but
We have a very low mic on you, I think. But
oh really?
Yeah, I can turn it up. You guys still chilling or done? All right. Maybe just a little breakdown or like some
Yeah.
behind the scenes for a couple minutes.
Indeed, yeah.
Because we got time and we're all chilling.
Mm-hmm.
Big Nerd Fest.
I accidentally ended the set early, actually. I used the wrong key binding and then stopped the track like half a minute before it should have ended. But yeah, all of this is being triggered using code. That's powering the synth. That's used to live loop my vocals. And I have this weird synth that makes only weird noises, and I love it. Costa here is using Touch Designer, so very relevant to tonight.
So I use Touch Designer for myself, but I also use early version, Stable Diffusion, Runway stuff, Mid Journey. So because we built all of these stuff for our tour in 2024, so something might be a little outdated because the AI models have been changing so fast. But I use Touch Designer for all my post-processing things. I also have a toolkit if you want to talk about the interface, whatever, we can. I'm willing to chat, connect. Yeah. Thank you, friends.
Oh yes, oh yes. Yeah, thank you guys. That was great. What is this background? I don't know. Ooh, ooh, ooh. Now we got a black screen. Are you able to somehow get those? That would be, yeah. We have another AV duo coming up next, and then another one after that. But yeah, we're going.
What?
You're looking for Don or Tyler? How many mics you need? I got two. Perfect. No mics? I'm gonna pocket both of them then. Alright. I'm MC ready. Thank you guys again. I'm super pumped to see you out so quickly from SF.
I'm very pumped. It was also fun to hear from Samantha and Costa, either beginning or end. You've got a full.
Hey Don, how's that look? Looks good? We good. Do you want me to keep you on? Or should I? Yeah, let's just go for it.
Beep, 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 beep. Everyone give it up for our Tyler visiting from San Francisco. And on visuals, Don Hansen visiting from Red Hook. I think there's one more act, so stick around.
Hello, hello. Oh, yeah.
got Pablo.
Hello.
Hello. Ooh, it's on. We're still nice. I see you well. Switching over. Oh, that's just your background. Switching over again. Wow. Wow. Oh my God. You want to switch over? We got it. DATFEST. Nice. All right, we got Laser, Luke, and Andre. Andre, we saw earlier give a talk with his awesome TD instruments and stuff, but yeah. Closing show.